You are about to master the core fundamentals of Docker by building a Node Express app with a Mongo and Redis database. Sanjeev teaches this course. He starts at the absolute beginning and then takes you through a full production workflow.
What's going on, guys? So in this video, I'm going to show you guys how we can set up a workflow for developing Node.js and Express apps within a Docker container. So the first thing that I want to do is I want to set up a quick and simple Express app that we can use for demonstration purposes. And the reason why I didn't actually prepare the Express app ahead of time is, first of all, this is going to be the quickest and simplest of apps. We'll be able to knock it out within like a minute. But I want you guys to focus on these steps that we need to actually create this app, because they're kind of important, because we're going to recreate those steps within the Docker container as well. So I've got my project directory. I called it Node Docker already here, and I've got it open up in VS Code. So, with any other Express app, the first thing that we have to do is get our package.json file. So I'm going to do an npm init. And that's going to create our package.json. And since we are creating an Express app, we're going to have to install Express. I'm going to do an npm install Express. So now we've got our dependency. The next thing that I want to do is also focus on the fact that we did create our node modules folder. So that happened when we installed Express. And the final thing that we need to do is actually create our application. So I'm going to create an index.js file. And I'm going to import our Express. So we'll do const express require Express. And then we can do const app equals Express. Right, then I'm going to specify the port that I want my Express server to live on. So I'm going to do const port. So this variable is going to represent the port that it's going to be listening on. And I'm going to set it equal to process.env.port pipe 3000. Right, so if you don't know what this line is, it's basically saying that if the environment variable called port has been set, we're going to set this variable to that value. However, if it's not set, we're going to default to a value of 3000, usually common configuration. And then we can do an app.listen, and we'll listen on that port. And when our server comes up, we can say console.log, listening on port, and then we'll pass in that variable. All right, so now the last thing that I want to do is set up a quick route for testing purposes. So I'm going to do app.get. And we'll just say the root path, and then we'll do rec res. And so if anyone sends a GET request to this path, we're just going to send back a simple response, which is going to be, we'll just send an H2 that says hi there. And I forgot the comma right here. All right. And so that's our entire Express app. I'm going to start this app real quick. So we're going to do node and then index.js. And it looks like I forgot to save, probably. All right. So it looks like I already had another Express app listening on port 3000. So I deleted that. So now, we do a node index.js, it should start. It's going to be listening on port 3000. We can go to our web browser real quick, and we can just go to localhost :3000. And when we do that, we should see it say hi there. I'll zoom in for you guys so that you can see that. And so that confirms our Express app works. So we've got our dummy Express app. So now we can go ahead and get started with actually integrating our Express app into a Docker container and setting up a workflow so that we can move to developing our application exclusively within the Docker container instead of developing it on our local machine like we just did. So now that we got our Express application complete, or the demo Express application, let's work on setting up our Docker container. Now for this video, I'm going to assume that you already have Docker installed on your local machine. If you don't, go ahead and do that now. Just follow the instructions on their website. It's fairly straightforward. Just make sure you follow the directions for your respective operating system. But once you have Docker installed on your machine, head on over to hub.docker.com, and I want you to just search for Node within that search bar right there. Once that's finished loading, you'll see that the first result is the official Node Docker image. So this is a public image provided by the Node team, and it's a fairly lightweight image that basically has Node already installed for us so that we don't have to do this ourselves. And if you take a look at the documentation, you'll see that we've got all of the various different versions that it supports. So you can get version 15, version 14, all the way back down to version 10 if you really want. And it's got directions for this image or any specific things that are relevant to this image when you want to deploy a container from it. Now, this Docker image right here is not going to have everything that we ultimately need for our application, because the whole idea behind Docker and an image is that the image is going to have every single thing that's needed for your application to work. And so for our application, we obviously need to get our source code into the image, and we also need to get all of our dependencies like Express, any other dependencies that our application may need. So to do that, what we're going to do is we're going to create our own custom image, and we're going to base this custom image off of this node image. So we're going to take this node image, we're going to copy all of our source code into that node image, and then we're going to install all of our dependencies like Express. And then that final image is going to have everything that we need to ultimately run our application. So let's get started on doing that now. Okay, so let's get started on creating our own custom image. To create a custom image, we need to create a Dockerfile. So the Dockerfile is just going to be a set of instructions that Docker's going to run to create our very own customized image. So let's create a new file, and we're going to call this Dockerfile with a capital D. Now in our Dockerfile, it's going to have a set of commands that Docker is going to run to create our own personalized image. And the first command that we always have to do is we have to specify a base image. So when you create a custom image, what you're ultimately doing is you take a base image or a known image of some sort, doesn't matter where the image is from. It can come from your own Docker repository. It can come from Dockerhub. It can come from anywhere. You just need a image that Docker has access to. And we're just going to tweak it a little bit so that it contains all of our source code. It contains all of our dependencies and things like that. So in this case, we already found our base image. It's going to be this node image because that's really the only thing that we need to run, right? We just need it to have node and anything else to run node. So we're going to take this as our base image. And the instructions here is going to show you how we can ultimately use that. So here you just specify node, and then you can do colon and then the specific version you want. If you don't specify the version, I forget what version it grabs, but if you read the instructions, it's probably going to say it grabs like version 14 or something like that, or maybe the latest version. Right. So what we do is we do from, and we'll capitalize from, and then we say node because that's the name of that image or our base image. And then we can do colon and then the version we want. So I'm going to specify version 15. Not that we need version 15. We can run 14 or really any version. We're not doing anything specific to any new versions. I just want to show you guys how to actually specify a version. So that's something that's absolutely needed. The next command is technically optional, but it's still recommended. And that's called the workdir command. And I'm going to set that to /app. So what this command does is it sets our working directory of our container to be the /app directory within the container. So I know this /app directory exists in the container because I've run the node image and I know it's got a /app directory. But setting the work directory is really helpful because anytime you run a command, when you set the work directory, it's going to run that command from this directory. So we can put all of our application code in /app, and we can run node index.js on /app. And it's going to run it automatically in /app without us having to specify. So the working directory just is the directory where you run all your commands, and it's also the directory where if you copy any files to your container, it's going to by default send it to this directory. So this is just recommended, but it's not technically necessary. Now the next thing we want to do is we want to copy our package.json file, which is this file, which contains all of our dependencies and anything else that we need. And we're going to copy it into our Docker image. So let's go to, so we can run the copy command. And so we copy the path to the package.json file, which is our current directory. So we just do package.json. And then we have to specify the directory we want to copy it to in our image. And so I'm going to do this dot, which means the current directory. And the reason why I do that is because we set our working directory up here to be /app. So when you do dot, it's going to assume the /app directory. We could technically also just do /app, same result, but since we have the working directory set, we can just specify it relative to that directory. The next thing is, once we have our package.json, remember it's got a list of all of our dependencies. We want to actually install our dependencies, so we want to run an npm install. So in our Dockerfile, to run a command, we can do run, and we can do npm install. right? So we now have our package.json file copied over, and then we run npm install. Now we've got Express installed for us. The next thing we want to do is, and this part's going to be a little bit confusing, but we're going to copy the rest of our files. So all of our source code, everything else, into our Docker image. So we'll do a copy again. And here, instead of specifying a specific file, I'm going to say the current directory. So this is going to grab every single file, every single folder within our current directory, and we're going to copy it to, just like we did here where we just did a dot, which is going to send it to the /app. We're going to do the same thing. So we can just do dot or /, same thing. And right here, you might be a little confused. You might be wondering, well, why do we copy the package.json first and then copy all of the files over? Do we even need this step before? If we're going to copy all of our files, this should copy our package.json, and it does. The reason why I split it up into two different steps is a little bit of an optimization technique. So let me explain how Docker images actually work. When you create an image from a Docker file, it takes each one of these steps and it treats it as a layer of the image. So you could think of an image as just basically these 5 steps or 5 layers. So once you build all 5 layers, you have the ultimate image or the final image. So this first command creates one layer of the image. This second command creates another layer of the image. This third command creates the third layer, the fourth layer, and the fifth layer. And they all kind of build on top of each other. And what's important is that after each layer, the Docker actually caches the result of each layer. And what I mean by that is when we run Docker build, when we actually build our image for the first time, what's going to happen is that it's going to run this first step and it's going to cache the result. So it's going to say, hey, look, we downloaded the node image from Dockerhub, and then we cache that result, right? We then set the working directory to /app, and we cache the result of that. We then copy package.json, we cache the result. We then npm install, cache that result, and then we copy all of our code and we cache that result. And this is important because let's say we decide to rebuild the image again, right? If nothing changes, Docker is efficient. It knows that nothing's changed in any of these layers, and it just takes the final cache result of step 5, which is the last layer, and it just gives that to you. So if you run docker build, which is the command to actually create the image, the first time you run it, it's going to take a long time because it's got to run all of these steps. And especially the npm install, if you have a lot of dependencies, it's going to take quite a while. But the second time you run it, if nothing's changed, you'll see it'll be done in less than a second. And that's because it's cached all of the results. And the reason this is important, and the reason why I split this up into 2 different steps is, I want you to think about what happens during our development process, right? When we are actively working on our code, what changes? Our package.json does not change very often, right? I mean, we do occasionally add new dependencies. That's normal, but it's, for the most part, your source code changes, but your package.json and your dependencies don't change very frequently. And so by splitting this up into 2 different steps, what happens is we cache each of these layers, right? And so we're going to cache the node image, we're going to cache the working directory, and in reality, those 2 will never change, right? We're never really going to change those 2. So we're always going to essentially cache the result from step 2 and onwards. But the thing about Docker is, if any layer changes, right, say that layer 3 changes, and what I mean by layer 3 changes is that if package.json ultimately changes, where maybe we add a new dependency, we have to rerun step 3 and all of the steps after that, because we don't know how that's going to impact step 4. We don't know how it's going to impact step 5. And so by caching, by splitting these up into 2 different steps, we can say that, listen, if package.json never changes, then we're going to cache that result. And since realistically, when we're actually programming, package.json is just not going to change. So we're going to cache that result. And since package.json is cached, then we're going to also cache the result of npm install because nothing's really changing. So we cache those results. And so when we change any of our source code within our application, the only step that really changes is layer 5, where we copy the rest of our code. And so we only need to rerun step 5. However, if we didn't have this split up into 2 different steps where we have a copy package.json and then copying the rest of our files, what would happen is that anytime we changed our source code, technically it would rerun everything, including the npm install, because it doesn't know that we only changed our source code. It just sees that, listen, this step where we copy all of our files has changed. We're going to have to rerun all of the steps after that. So by doing this, we know that package.json will always be the same. So we can cache the result of these 2 steps and only make and only runs step 5, which is the changing of our source code. So it's a little bit of optimization. If it didn't make sense, I don't think I did that great of a job of explaining it, but I'll show you guys this when we actually build our containers, how it actually caches the results of each step, and how it's a little bit of an optimization to actually do this and split this up into 2 different steps. All right, so the next thing that we want to do is we know our application is going to be listening on port 3000. So let's do expose. So we're going to say our container is going to expose port 3000. And then finally, when we start our container, we want to tell it what command to run. Right? And since this is a Node application and our entry point into our Node application is this index.js, we have to tell it to run index.js. So we do cmd brackets, and then we're going to do node and then index.js. All right. So when we deploy our container, it's going to run in index.js. So this is at runtime and this is at build time. So hopefully you guys understand this. So this is when we're building the image. This is the command that's going to be assigned to the container when we actually run the container. And so that's all we really need. We're going to go ahead and actually create our image now. So let's go to our terminal down here. And I'm going to stop our Express server because remember, we're no longer going to be developing on our local machine. We're going to be developing on the Docker container. So make sure you stop your local instance of your application. All right. And let's build our Docker container. Oh, sorry, our Docker image. We're building the image right now, not the container itself. So we'll do a Docker build. And then we're going to specify the path to our Dockerfile. It's actually called the context. It's not necessarily the path to the file. It has a little bit more of a meaning to it, but I don't want to spend too much time going on it. Just think about it as the path to the Dockerfile. So this Dockerfile is in the current directory, so we're just going to do a dot. So let's run that. And I realized I forgot to save my file, so let's save that. And I'm going to rerun that. And I want you to pay attention to the output. Notice what's happened. And I think this is kind of important when you're trying to understand what's happening. You can see that on step 1 of 5, it says we're going to grab the node image from docker.io. So it's pulling the image from the from Dockerhub, right? And as I said, each one of these is a separate step or a separate layer, right? And if we go down, we go to step 2, and it says working directory is set to /app. You can see that it says cached. So you're not going to see it say cached on your machine. That's because I ran this as practice before I recorded this video. But it's not going to say that it's cached when you ultimately run this. So keep that in mind. But if you run this again, right, what should happen is that it should cache all of the results, right? And so now all the way down to step 5, it's cached. So if you run it again, like I said, there's an optimization where it actually caches the results. And the second time you run it, it's going to be much, much faster. So now what we're going to do is we're going to do a Docker image ls, and you can see the new image it created. This is the one without a name because we didn't specify a name. You also see the node image that it pulled from Dockerhub, which is node 15. Now, I don't like the fact that we didn't give this a name. So let's do a Docker image rm. This is going to delete the image that we just created. And I'm going to pass in that image ID. And if we do a Docker image ls, you can see that it's gone now. So now we're going to go back to the Docker build command that we ran, but this time we're going to pass in a specific flag. So we'll pass in the -t flag. So here we can give it a name. I'm going to call this node-app-image. All right. So once that's complete, we'll do a Docker image ls. And now you can see we've got our image that we just created. So now that we have our image, let's go ahead and run it and let's test it out, see if everything works. So we'll do a Docker run, and we'll do node-app image. So here we're just specifying the image that we want to create a container from, which is this image that we just created. But before you hit enter, there's a couple of flags that we got to pass. So first of all, I want to give my Docker container a name so that I have some kind of way to identify it. So we can pass in the -name option, and we'll call this node app. So keep in mind that last entry in my command is the name of the image that we're creating a container from. This is the name of the container that we're creating. And then finally, there's one more flag I want to pass, which is -d. So that means it's going to run in detached mode because by default, when you create a Docker container from Docker run, you're going to be attached to the CLI or the console or whatever it's called. But here I can run it in detached mode so that my command line's still free and open. So let's hit enter. And it looks like it successfully created my container. I can do a Docker PS. and we should see that there's a container open at the moment. All right, so let's test this out. And what I'm going to do is let's just go to my localhost :3000, hit refresh, and let's see what happens. All right, so it doesn't look good. It's spinning, which most likely means there's something broken, and it looks like there is. Don't worry, guys. I know exactly what's wrong. I purposely did this. So let's tackle exactly what's wrong with our Docker container in the next section. So we were unable to connect to our Docker container on localhost :3000. Now, why exactly were we unable to do that? Well, let's take a look at our Dockerfile. And if we go back here, we can see that we do have this command expose 3000. And I think naturally most of us would assume, hey, look, we're exposing port 3000, so we should be able to access that. Well, not exactly. This line does absolutely nothing. This is really more for documentation purposes. If you delete this command and create a brand new image, it will not impact our image or container at all in any way, shape, or form. It's just so that when you share your Dockerfile with someone else, they'll know, hey, look, this image expects you to open up port 3000 for everything to work. So this line doesn't actually open up port 3000. And the thing about Docker containers is, by default, they can talk to the outside world. So if a Docker container wants to reach out to the internet or wants to reach out to any other devices in your host network, it can do that. However, outside devices like the internet or your host machine or any other machine from the outside world, by default, cannot talk to a Docker container. This is almost like a built-in security mechanism, right? You don't want the outside world to be able to access your Docker container, but your Docker container can access them. So how do we make it so that the outside world can talk to our Docker container? And keep in mind, when I say outside world, I don't just mean the internet. I also mean our local host machine, right? And when I say local host machine, I mean my Windows machine right here, right? To actually talk to the container from my computer, which is kind of seen as like an outside device, we have to poke a hole in our host machine. And what I mean by that is that by default, right, our Docker container, nothing from the outside world can talk to our Docker container. So we have to basically say on our host machine, hey, if we receive traffic on a specific port, we want to forward that traffic to our Docker container. And the way we do that is, it's very easy. First of all, let's kill our container. We don't need that anymore. So I'm going to do a docker rm and then specify the name of our container. So we'll do node-app. And then I'm going to pass in the -f flag. So this stands for force. So by default, usually you have to stop a container before you can delete it. If you pass the -f flag, it'll allow you to delete a running container. All right, so now if I do a docker ps, we should see an empty list. So let's do docker, let's rerun that command. But here I'm going to pass in another flag. We're going to pass in the -p flag. I'm going to specify this. So let me explain what this is in a second. So we've got port 3000 and then :3000. So what exactly does this mean? We've got two different numbers. We've got the 3000 to the left of the colon and 3000 to the right of the colon. So the number to the right, let's start off with this one, is the basically the port that we're going to send traffic to on our container. And our container, remember our application's listening on port 3000, so we want to send this to port 3000. Right? If this was set to 2000, then we would want to set this to 2000. So whatever our container is expecting traffic on, the number to the right of the colon should be set to that value. Now, the number to the left represents traffic that's going to be basically coming in from the outside world. So if another device on your network or even your local host machine, right, my Windows machine, if we send traffic to localhost port 3000, right, we're going to take traffic that's coming in on port 3000 and sending it to port 3000 on our container. But in this case, even though the two numbers are the same, they don't have to be. So let's say we wanted to basically poke a hole so that anybody that sends traffic to our Windows host machine here on port 4000, we should then forward it to our Docker container. In that case, we would change this to a 4000, and we would keep this to port 3000 because remember, it's still listening on port 3000. However, if this was 2000, then we would change this number to be 2000 here, right? So hopefully that makes sense. I've set up a little quick diagram. I don't know if you guys understood it at this point, but hopefully the diagram makes it a little bit easier to understand. So let me pull that up. So here in this diagram, I've got my host machine, right, which is this big blue box, which is my Windows machine. And then I've got this node container in green right here. And so what's going to happen is, we've got those two numbers, right? Basically, what we want to do is when our host machine, right, our Windows machine receives traffic on port 3000, what we want to do is we want to take that and forward it to port 3000 on our node container. So that's why we have 3000 colon 3000. So the first 3000 represents the red arrow, and then the second 3000 represents the yellow arrow. And this also applies when we send traffic from our host machine to the local host IP, so to ourselves. So if we send traffic to localhost port 3000, it's going to take that traffic and it's going to forward it to port 3000. And once again, like I said before, we don't have to do 3000 to 3000. We could change this to 4000, and then we would send traffic to localhost 4000, and it would forward it to traffic on port 3000 on our node container, because once again, our node container is listening on port 3000 because that's what our Express server is listening on. All right, so hopefully that made sense. I'm going to run my container now. So I'll hit enter. And I changed everything back to 3000 colon 3000 because that's just a little bit simpler. Why not have both of those numbers match? There's no need to unnecessarily complicate things. Let's do a Docker PS. All right, and you'll see that we've got our container, but we under this port section, you can see that it looks a little different. You can see that right here, we've got basically 0.0.0.0 on port 3000 with an arrow to 3000/TCP. So what this is saying is any traffic destined to your host machine for my Windows machine right here on port 3000 is going to get forwarded to port 3000 on my container. So now let's go back to their webpage and let's do a refresh. And you can see now it says hi there. So we have successfully sent a request to our Docker container on port 3000. Now, before proceeding any further, I do want to show you one thing real quick. Let's actually log into our Docker container and take a look at the files in there. So we can do that by typing in docker exec -IT for interactive mode, and then we'll specify the name of our Docker container, which is node-app. And then we want to pass in a new command instead of the usual node index.js. We're going to pass in bash. So this is going to allow us to take a look at the file system of our container. So here, by default, it's going to drop us in the /app directory just because we set the working directory to be that. And here, I just want to type in an ls. So this is going to list all the files in that directory. And so you're going to see all the files that are copied over. So we've got our package.json, we've got the package.lock, we've got the node modules folder, our index.js, and we've got the Dockerfile. And, the reason why I wanted to show you the file system is you may be wondering, what is our Dockerfile ultimately doing in our Docker container? Right, our Dockerfile is there to create an image, but we don't actually need it in our Docker container. And I also wanted to point out one more thing. If you take a look at this copy command right here, what it does is it copies everything in our current directory, so every single file, and it copies it into our container or our image. And this is a bad thing because there are going to be files that you don't actually want copied into your container, right? Just like our Docker file that I mentioned, we may also have an environment file that has a lot of our secrets that we don't actually want copied into our container, potentially. Also, on top of that, we don't need to copy our node modules folder. This is actually a waste of time because a lot of times this folder is actually fairly large, and we don't need to do that because remember, we're copying our package.json file and then we're doing an npm install. So there is zero reason to ever have to copy this node modules folder into our container. And on top of that, we ultimately want to move away from developing on our local machine. So moving forward, we won't even have a node modules folder on our local machine. It'll only ever exist within our Docker container. So why are we even copying it in the first place? It could be stale. We may not even have it. So we need to find a way to make it so that Docker does not copy over files that we don't ultimately want copied over. Just like this Docker file, just like the node modules folder. If we have Git configured, we definitely don't want that copied over. And so we can do that by creating a Dockerignore file, right? And that probably sounds a little familiar because if you work with Git, Git has a Gitignore file for files that you don't want checked into your Git repository. Same exact concept. So let me exit out of my container. So we can do exit to exit out of the file system. And I'm going to kill that container. So we'll do docker rm node-app, and then we'll do -f for force. And let's create a Dockerignore file. So I'll do a new file. And I'm going to call this dot or period, and then Dockerignore. And within our Dockerignore file, we're going to list out every single file and folder that we don't ever want copied into our Docker container. So the first thing is we don't want to copy our node modules folder. because we're going to do an npm install from our package.json anyways. There's really no need to ever copy it over. We don't want to copy over our Dockerfile. Now that we have a Dockerignore file, there's really no need to copy that into our Docker container. And then a few other things, right? If you have Git, you don't want to copy Git. You don't want to copy your Git ignore. For now, I think that's good. You'll see later on in the video, we'll add a couple more files, but for now, that's okay. Just do a save. And now let's rebuild our image. So let's find that build command. So docker build -t, the name, and then the path to the Docker file. So that's their current directory. So we'll run that. Let me just make sure I didn't change anything in my index.js. Yep, everything looks good. So let's run that. All right, so that's done. Let's run our container from the new Docker image that we just created. So if we hit up for that Docker run command, let's see if I can find it. Here we go. So Docker run -p. So we're going to open up port 3000, run in detached mode. We're going to give the container a name of node-app, and we're going to use the node app image that we just created. All right, so we did that. Let me just quickly double check to make sure I didn't break anything. So we'll hit refresh. It looks like everything's working. Perfect. Now, let's go into our Docker container again. So we can run that docker exec command. And let's just make sure it didn't copy over any unnecessary files. So let's do an ls. And now it's perfect, right? We no longer see a Docker file. There's no Dockerignore file. I can't verify for you guys that we didn't copy over the node modules folder, but just trust me, this node modules folder is from running an npm install on the 4th step, and not because we copied it over from our local machine. All right, so let's exit out of that. Okay, so now that we got our application working in a Docker container and we can access it from our local machine, let's see what happens when we change our code. I'm going to go back to my my index.js file, and I'm going to just tweak something. Right here it says we're sending an H that says hi there. I'm just going to add a couple of exclamation points. We'll save that. And I'm going to minimize this, and let's hit refresh. Let's see what happens. We hit refresh. Nothing happens. We don't see the exclamation points. So for some reason, our code didn't get updated. And I want you to think about why that is. It's actually a really simple answer, right? Basically what happens is, first of all, we have to take our Docker file, we have to build an image. So we built an image, and then we built a container from it. Now we changed our code to add the exclamation points, but our image that we created from our Docker file was run before we made these changes. So the code in that image does not have the exclamation points. And so basically our image has a stale version of our code, which means our container, which is running from that image, has a stale version of our code. And we can prove that. If we do a docker exec and go into our code, if I do an ls, we can see our index.js file, and I do a cat, which is just going to print the contents of that file. If I do an index.js, you can see that there's no exclamation point. So it's running a stale version of the code. So how do we actually update that? Well, it's actually very simple. First of all, make sure you save all your changes. And now what we're going to do is we're going to rebuild that image. Well, first of all, let's delete our container. We don't need it anymore. And let's rebuild the image. So where's that build command? So build. Right. So now if you take a look, you'll see that because our source code changed, it had to run step 5 once again. So now, if we do a docker image ls, this new image, which we named it as the same name as we had before, now has the new exclamation points built into the image. So if we deploy this image with a docker run command, it's the same exact docker run command, hit enter. And now if we go back to our web browser, hit refresh, we can now see the exclamation points. So that explains why our code didn't automatically get updated. However, I'm sure you're thinking, well, this is kind of a strenuous process for when you update your code, right? Every time I make a change, I don't want to have to rebuild an image and redeploy a container. That's a very slow process. That's going to slow down your development time. And what I'm going to do is I'm going to show you guys how we can work around that, because that's obviously not sustainable. You can't be rebuilding an image and rerunning a container every time you make one tiny change in your code. So what we're going to do is we're going to make use of something we're going to make use of volumes. So within Docker, we have volumes, which allows us to have persistent data in our containers. but there's a very specific type of volume called a bind mount in Docker. And this is a special volume because what it allows us to do is allows us to sync a folder in our local host machine, in my Windows machine in this case. It allows me to sync a folder or a file system to a folder within our Docker container. So what I can do is I can take all of these files and sync them into the /app directory of our container so that we don't have to continuously rebuild the image and to redeploy a container. Every time we make a change, it'll automatically sync those two for us to really speed up the development process. So let me show you guys how we can do that. So we're going to delete our container. All right, and what I'm going to do is we don't need to rebuild our image. The image is just fine. But I'm going to hit up a few times so we can get to this run command. So we're going to use the same exact run command. And we're going to pass in a new flag. Doesn't matter where you put it. And it's going to be the -v flag. So this stands for a volume. There's a couple of different volumes or different types of volumes, but remember, we're using the bind mount, which is a special volume that allows you to sync a folder from your local machine to a folder in your Docker container. And so the syntax for this is you do -v and then you specify the local folder or the path to the folder on your local machine. So I'll just say path to folder on local machine, on local, and then we do colon, and then we do path to folder on container. Okay. So kind of like pseudocode, just so you guys understand. So this is going to be the location of this folder, right? Because this is the folder that has all my source code, and I want to sync that to a folder within our Docker container. And that's going to be in the /app directory because that's where we're going to store all of our source code. So let's hard code those values. And so here, unfortunately, I can't just do a dot right here. It's not going to register that. It's not going to work. You have to actually pass in the whole path. So if you're using VS Code like I am, you can right click here and then just select copy path. And then you can right click and it's going to grab the entire path in my host machine to this folder. Obviously, I'm going to delete the Docker file section. We just need to get into the node Docker, which is the name of the folder that houses all of my code. And then we do colon, and then we do the path to the folder in the container. So what folder do we want to copy it to? Easy. We want to copy it to /app. Right, and that's all you have to do. You hit enter and it's going to sync your code. However, I do want to show you a couple of shortcuts because that does look a little messy having to type all of this out. And so what we can do is we can make use of variables. And so I'm going to delete this. I'm going to show you guys what you can do instead of having to type out that whole nonsense. And it's going to be different based off your operating system. So if you're using Windows and you're using the command shell, then what we can do is we can type in %cd%. So that's going to grab the current working directory. So that way I don't have to copy that entire path. That only works on Windows command shell. If you're using Windows PowerShell, then you're going to have to type in $, curly braces, pwd, closing curly braces. That's going to grab the current working directory. And if you're on a Mac or a Linux, then you can type in $, parentheses, pwd, and then close parentheses. So that's just a shortcut, or you could type out the entire path. Whatever is easiest for you, feel free to do that. So I'm just going to use my %cd%. All right, and so let's hit enter. And depending on what operating system you're using, if you're using Windows, anytime you're doing file sharing, you might get this warning. There's a couple of optimizations that you can make. I usually just ignore it for now. All right, so now theoretically, it should be syncing this entire folder with the /app directory in our container. And so let's minimize this. And let me just refresh this. So you can see right now, we've got the 4 exclamation points. Let's go back to our code. And I'm going to delete the exclamation points. All right, and then after we delete it, let's save it. And let's see if I refresh this page, does the changes take effect? So let's hit refresh. And it looks like it didn't. So do you guys know why it didn't take effect? Well, let's take a look, right? Because theoretically, this command this flag right here should sync the folder. So we should see this file get synced to our container. So let's drop into our container and take a look at what the file looks like in the container to see if it actually updated. All right? Because maybe I was lying to you guys and this does absolutely nothing and I wasted your time. So we log in. Let's do an ls. So we've got our index.js and let's print out the contents of the file by typing in cat and then index.js. And if we take a look at that, we can see that, hey, look, it did actually sync our code. It deleted the 4 exclamation points. So why exactly did we not see the update in our web browser? Well, this is easy. For anyone that's ever worked with Express applications, I'm sure you might have an idea as to what exactly caused this problem. Remember, anytime we make changes to code in a Node or Express application, we have to restart the Node process. We did not restart the Node process. We just changed the code and we hoped that it would automatically work. But we had to restart the Node process. Right? And, we could go in, we can kill the Node process, start it again. But obviously, that's inefficient. Right? We already have a solution that we already know is going to work. And that is we're going to make use of NodeMon. Right? NodeMon will always look at your code. And if any changes take place, it's going to restart the Node process so that the changes are updated in real time. So let's get that set up and installed. I'm going to exit out here and we need to update our package.json file. So let's get NodeMon installed as a dev dependency. And I'm going to do this on my local machine just so that we can have it set up in this file. So I'm going to do an npm install NodeMon --save dev. So this is going to be a dev dependency just because we don't need it to run when we actually deploy to production. And remember, I'm just doing this on my local machine right now just so that we can update my package.json file. All right, so we've got our dev dependency. Now let's go to my package. Well, I'm already in my package.json, but let's set up a few scripts. So we'll do a start, and this will just be the usual node index.js. And then we'll have a dev, which is going to be, a NodeMon index.js. So by running NodeMon in dev mode, it's going to automatically restart it's going to restart the node process anytime there's any changes to our source code. Now, as a heads up, when I was doing a dry run of this demo, I did run into some issues on specifically, it looks like Windows machines. So if you're on a Windows machine and for some reason later on in this video, you run into some issues with NodeMon not actually restarting, you may need to pass in the -l flag. So that kind of fixed most of the issues. If you do run into the issue, just try the L flag. If you want to read up on it, just Google the error message that you get, or just Google NodeMon not restarting on Windows for Docker, and they'll give you an explanation for why you need to pass in that flag. But I'm going to keep that in there because I'm running a Windows machine and I did run into that issue. So let's save all of that, and let me kill the Docker container that we have. So I think there should be one running. So we'll do a Docker rm node-app-f. All right. So now that we made changes to our package.json, we're going to have to rebuild our image now. So we'll do a Docker. Let me see if I have that command cache someplace. Here we go. Build. So we'll do the Docker build. And notice how it's taking a little bit longer this time. And that's because our package.json file changed. So it had to rerun step 3, where we copy package.json, and then rerun step 4, and then rerun step 5, because we have to run all the steps after that, because we don't know if changes to this file changed any of the cache results. So that's why it took a little bit longer this time. But hopefully by now you guys get an understanding of how all the caching works in Docker. All right, so now let's redeploy. Actually, before we redeploy, there's a couple of things that we have to change. I realized I forgot to do this. So back in our Dockerfile, right, we're not going to run node index.js anymore. So in the development mode, we're actually going to run, if you take a look at our package.json, we're going to run npm run dev so we can run NodeMon. So let's go back to our Dockerfile. We'll do npm run and then dev. Save that. Sorry about that, guys. We're going to have to rebuild our image again. So let's rebuild it. All right. And so now let's run a container from that image. And this time we want to do it with the bind mount again. Let's hit enter. We've got our Docker container. Let's quickly test this out. Okay, so the exclamations are gone, which is fine. And let's make a quick change to our code. I'm going to re-add the exclamation points. Save it. All right, and if I hit refresh, look at that. So it looks like NodeMon's doing its job, and anytime we make changes to our code, it's automatically restarting the node process, and our bind mount is successfully syncing the code from our local machine to our Docker container. Now, I want to do a quick little test, and I'm going to do this because I suspect, depending on how you guys followed along to this video so far, you may have run into an issue in the most recent step. So let me delete my Docker container. So let's do a docker rm node-app-f. And what I'm going to do is I'm going to take this node modules folder on my local machine, which I don't need anymore because we're not developing on my local machine, and I'm just going to delete it. All right, so now that it's gone, I'm going to redeploy the container. I'm going to show you that we're going to break our application. So it's now running, and if I go to my web browser, hit refresh, you can see it spins and it's eventually going to crash. Let's give it a second. There you go. So what exactly happened? Well, let's take a look. So if I do a docker ps, let's see if my container is running. And look, that's the first issue. Why is our Docker container not even showing up on this? Well, when you do a docker ps, it's only going to show you running containers. So let's do a docker, I think it's ps minus af. Yep. So this is going to show you all containers started or stopped. And you can see our most recent container, our node app container, and it said it exited 30 seconds ago, which means usually if it automatically exited, it usually means something crashed. So if you want to take a look at the logs to see why something crashed, we can always do a docker logs, and then you specify the name of the container. So this is going to give you all the logs for that. And this is going to show us some node or nodemon logs. And you'll see right here, it says nodemon not found. So what exactly is happening? We know for a fact that nodemon should be installed because we had everything working before. The only change we made was we deleted the local node modules folder. Why should that impact anything? Because it was working before. Well, let me tell you what happened. So what happened was, we create our Docker image, right? Where we copy our package.json file, and then we run an npm install. So at this point, when we run npm install, it should install nodemon for us. And it is in there. But then we copy all of our files, which once again, not an issue actually. I don't know why I kind of made it seem like it was, but we copy all of our files, all of our source code, and then the command specified for the container is npm run dev. Now, when we go back to our Docker command that we used to actually create our container, we created a bind mount. So the bind mount syncs this folder with the /app folder. And this is where the issue occurred. Because it's syncing this folder, since there's no more node modules folder in this folder, it syncs that with the /app folder. So it ends up overwriting the /app folder and deleting the node modules folder in the /app folder of our container because it doesn't exist in our local directory. And since we have a bind mount, it's going to sync those two directories together. That's the problem, right? Because once we deleted the node modules folder from our local machine, it will also delete it from our Docker container. And then without the node modules folder, that container has no idea what the hell nodemon is. So how do we get around this issue? How do we prevent our local directory, our local folder, from overwriting the /app directory and deleting the node modules folder? Well, there's a simple little hack that we can do, and that is we're going to create a new volume. And we're going to create a volume that's called, there's a couple different volumes, like I said, in Docker. A bind mounts one. We also have an anonymous volume. And volumes work based off of specificity. So we've got a volume on our container for the /app directory. But we want to make sure that we preserve the /app/node modules. So we want to make sure this bind mount doesn't override the /node modules folder within the app directory. And the way we can do that is we could just specify another volume. So first of all, let me delete our broken container. All right, and then we'll run that same command, but I'm going to pass in another v flag for another volume. And I'm going to say this volume, which is going to be an anonymous volume, is going to be for the /app/node_modules. This is a little hack that you can do to prevent the bind mount from overriding the /app/node_modules folder, because all volumes in Docker containers are based off of specificity. So even though this bind mount should sync with the /app directory, we can see that we have another volume that references the /app/node_modules folder. And you can see that since this is a longer path, that's basically more specific. So that's going to prevent this bind mount from deleting the node modules folder. Basically, this extra line is going to say, hey, don't touch this folder since it's a more specific, it's a longer path, it's more specific, so it overrides the bind mount. The bind mount will still sync all of the other files, it just cannot touch the node modules folder. All right, so now if we hit enter, let's do a Docker PS, and it should stay running. Let's just make sure it didn't crash, and it looks like it didn't. So now if we go to the website, let's hit refresh. It's there. Let's make a few changes just to make sure nothing else broke. We'll delete the exclamation points, hit save, and then hit refresh. And it looks like everything's working. Everything looks perfect so far. Now, there's one thing I do want to point out. So you'll notice that we do a copy where we copy all of our files into our container at the build stage. And you might be wondering, well, do we really need to do that if we have our bind mount? And the answer is yes, because the bind mount is really just for our development process. We only use the bind mount when we're developing because that's when we're changing our code. When we go to actually deploy in production, there obviously isn't going to be a bind mount because why are we changing our code in production? So we still need this copy command for when we deploy into production because there is no bind mount and we have to make sure all of our source code gets copied into the image for our production container. All right, guys, so when it comes to Docker volumes and bind mounts, I want to show you one last thing. We're going to make one slight change. Not required, but it's kind of best practice. So what I want to do is I have my container still running. If you don't, go ahead and just run this command again, where you have the bind mount and the anonymous volume. And I want to drop into bash so that we can take a look at the file system. So we'll docker exec-it app and then bash. All right, so we're in our container and let's do an ls. And so remember, since we have the bind mount, this directory is going to sync with the directory in our container. However, it's a two-way street. So if I make changes here, it's going to get updated here, right? If I do a new file and I'll just say my file and I do an ls here, right? We can see my file. However, if I create a file within my container, it's going to add it to my local machine as well. So if you want to create a file, just for demonstration purposes, you can type in the command touch. It's going to create an empty file, and I'll just say test file. So if I do an ls, we created our test file, and you can see the file showed up on my local machine. I want you to think about a potential issue with that. Why is our Docker container changing our files? Is there ever a scenario where you want your Docker container to actually be making changes to your source code or any of the files associated with your source code? Probably not, right? It seems like almost like a security issue for it to even allow it to do that. Right? There may be certain instances where your application actually creates files on the local machine, and in that case, you might want to allow it. But for the most part, you don't want your Docker container being able to touch any of your files or make any changes to it because there's really no need to. And so what we can do is we can take our bind mount that we created and we can make it a read-only bind mount, which means the Docker container will be able to read any of the files, but it can't touch any of the files and it can't create any of the files, right? It's read-only. So let's get started on that. We'll exit out of here and I'm going to kill this container. And to make this a read-only bind mount, it's very easy. So let's run this command. Where'd it go? There we go. Let's run this. And all we have to do is specify colon at the end of /app. We do colon RO. And that implies read only. So we'll hit enter. Hopefully it's running. And we're going to go and drop into bash to our container. All right. And so now here, let's create a file. So we'll do touch, new file. And look at that. It says this is a read-only file system. It cannot make any changes. It cannot create any new files. It cannot edit any files. Everything is read-only. So this is a little bit of a an enhancement that we can make so that it protects our source code and it doesn't allow our Docker container to do any kind of funny business with any of our source code. All right, so let's exit out of here. And I'm just going to do a little cleanup. I don't need these files. All right, and now what I want to do is I want to show you guys how we can start making use of environment variables within our Docker container. So if you go back to our index.js file, and you remember our Express app, the port it's going to listen on is going to be based off of an environment variable called port that we pass in. If this variable is not set, it's going to default to a value of 3000. So how do we make use of environment variables within Docker containers? First of all, let's go to our Dockerfile, and we're going to specify a default value for our port variable. So after our copy command, doesn't technically matter where you put this, but we can say env. So this is referencing environment variables. We're going to create one called port. And we're going to say the default value for this environment variable is port 3000. And then we want to expose, remember, this is just merely for documentation purposes. This command doesn't really do anything. Instead of having to hard code 3000, what we can say is we can reference this port variable by passing in a $sign and the name of that variable is port. So if this gets updated, this will automatically get updated as well. So let's save that. And what we want to do is, let's see, do we have any containers running? Yep. So let's just kill that. All right, and let's rebuild our image because we made a change to our Docker file. And we can do a Docker build for that. All right, so now that those changes are made, our application shouldn't really fundamentally change because now we're just setting our environment variable to be port 3000. Before it was defaulting into a value of 3000, but now since the environment variable is set to 3000, everything should theoretically work the same. It's just now going through that environment variable. But what I want to do is when we actually deploy the container, we can specify what value we want that environment variable to be set because this is just the default value. We can always override it. So let's deploy a new container with the same exact command with both of our volumes, but we can pass in an environment variable by passing in --env, or you can just do a single dash and the letter E. So whichever you prefer. I don't know why I prefer the --env, but whatever you prefer. And then you pass in the name of the environment variable equals, and then whatever value you want it to be set to. So let's say we want our Express server to listen on port 4000. Now it's going to change to 4000. However, before we hit enter and actually create our container, remember, since our Express application is listening on 4000, we have to change the port that we're sending traffic to. Because right now we're sending traffic to our container on port 3000, but our Express app is listening on port 4000. So we have to change this to 4000 or then our application is going to break. We don't need to change the port that we have to hit on our local machine. We could technically change it to 4000, but it doesn't really matter. You can pick any value really here. So let's hit enter. And let me just make sure it's running. All right, so it's running. So now if I go to the web browser, hit refresh, it looks like it's working. Just to double check everything's working fine, let's just make a few changes to add the exclamation points back. Save, hit refresh. It looks like everything's working. Just to double check, I do want to make sure that the environment variable did get set. So we can drop back into that container again like we always do. Where's that command? Docker exec. So in a Linux machine, if you want to ever see the environment variables, you just type in print env. And so here we can see that the environment variable of port equals 4000 was set. And so that confirms that when we ran our Docker run command and passed in the --env flag, we were successfully able to overwrite the port variable or the port environment variable that was specified in our Docker file. Now, when it comes to your application, you may have more than one environment variable. Actually, you most certainly will. And if you have a lot of environment variables, you can pass in the --env flag as many times as you want. So if you wanted to, you can say where'd it go? Here we go. So if you wanted to pass in another one, you can just do --env and then whatever that variable is. However, if you've got like 10, 20 environment variables, that's kind of a little bit of an exhausting process. And it's a little bit of a pain. And so what you can do instead is we can actually create a file that stores all of our environment variables. So here I'm going to call this, you can call it whatever you want, but standard convention is .env. And here we can just specify port equals 4000. Right, and so that's going to essentially do the same thing. And here you could just provide a list of all of your environment variables. And let's save that. And I'm going to kill my Docker container real quick. All right, and so now if you want to load environment variables from a file instead of having to pass each one line by line, let's go to that Docker run command and we can remove the --env. And we can pass in -env -file, and then the path to our environment variable. So from our local directory, we do // and then .env. And so that's going to grab this environment variable file and then all of the environment variables stored in here. I think I saved it. Yep. And let's hit enter. Hopefully this works. Let's go Docker PS. All right, it's running. I'm going to log into the container and do a print env. Let's just make sure that it's set, and it looks like it's set. So those are the two different ways to specify an environment variable and to set environment variables for your Docker container so that your application can get the necessary data that it needs. Now, one thing I want to point out is as you've been creating Docker containers and deleting them, if we do a Docker PS, you'll see that we just have one container running. If you do a Docker volume ls, this is going to list all the volumes that you have. And you can see that we've kind of built up a couple of different volumes. And you might be wondering, what are these from and why are they building up? And as you keep creating containers and deleting containers, they're going to slowly build up over, and you'll eventually end up with hundreds. And the reason for that is if you take a look at the command that we're running for our Docker container, this volume that we specified right here for the /app/node modules hack, this is an anonymous volume. So every time you delete your container, it's going to preserve that node modules folder in here. And we don't actually need to preserve it, right? Because we're going to be deleting and creating new containers all the time. So you can go in and manually delete the volumes, right? You can always do a Docker volume rm and then specify the volume name, or you can do a Docker volume prune that should remove all unnecessary volumes. But if you want to make sure that these volumes don't build up, usually what I like to do is when you do the Docker rm command, it's not going to delete the volumes associated with that container. So if you want to delete the volumes, which in our case we do, there's obviously plenty of instances where you don't want to delete the volumes because the whole idea behind a volume is that it's persistent data. You want to preserve it. So like if you have a Postgres database or a SQL database, right, you want to preserve all your database records. So you would never want to delete that. But in our case, we just have an anonymous volume so that we can get around that limitation that we ran into before. So when you delete a container, just pass in the -v flag. When you pass in the -v flag, it'll make sure to delete the volume that's associated with that container so that it doesn't build up. So for now, I'm just going to do a Docker volume. I think prune should work. It's going to say hit yes. Let's see if I do a Docker volume ls. You can see that it's deleted all but one, and this is the volume that's associated with the container still running. So if you want to do the Docker, that little trick I just showed you with the running container, where is that? Here we go, -fv. It's going to delete the container, and it's also going to delete the volume as well. So moving forward, do the -f and then v so that you can delete the volume as well. So now when it comes to creating our container, we've kind of set up a nice little quick workflow for developing a Node or Express application in a Docker container. However, the command to run the Docker container, this command right here, is kind of long. And, I don't want to have to rerun this command every single time I want to get my container up and running. Although I'm sure you're thinking, well, you can just hit the up arrow key, so it's not a big deal. And that is 100% true. However, keep in mind when you're actually developing, like an Express application or some kind of Node application, you're probably going to have more than one Docker container, right? Right now, we're just building the Express server, but in a full-blown application, you might have a container for your database. You might have an Elasticsearch container. You might have another container for Redis. You're going to have multiple containers, right? And each one of those containers, you're going to have to run a command that's this long or potentially as long. And at that point, it starts to become a real hassle of getting your entire development environment up and running, and even getting your production environment up and running, because you're going to have to run 5 or 6 Docker commands. And you have to make sure there's no typos or anything like that. So what I'm going to show you guys is a way we can kind of automate all of these steps so that we don't have to run this monstrosity of command. And we're going to use a feature called Docker Compose, where we can create a file that has all the steps and all of the configuration settings we want for each Docker container. So we can say like, hey, I want to create a node container using the image that I created, and I want to create a volume for the bind mount, and I want to create an anonymous volume. I want to pass in the environment files, and I want to open up these ports. So you can pass in all of these steps into a file, and then you can just run one very simple command to bring up, as many containers as you want. So if you have like 6 or 7 different containers in your development environment, you can bring up all 6 or 7 all at once with one command and bring them all down with one command. So let me show you guys how to do that. So what we're going to do is we're going to create a Docker Compose file. And so what we're going to do is we're going to do a new file. We're going to call this docker-compose.yml. So that stands for YAML. It's a certain type of syntax that you use. So what we want to do is, with your Docker Compose file, the first thing we have to do is specify the version that we're going to use. Now, if you go to this website right here, it's going to show you all the different versions of Docker Compose and the features that they support. Now, we're not going to do anything crazy, so I'm just going to use version 3, but if there's a specific feature that you need, then you're going to have to make sure you grab the specific version. This web page has a list of all the features that each version supports. So you can just take a look at this page and see what's the minimum version that you need to actually run all the specific features that you want. But I just default to version 3, so we'll say version, and then 3. Now, the next thing we want to do is we want to specify all of the containers that we want to create. And so within our Docker Compose file, each container is referred to as a service. So we do services, and then we just specify all of our services. Now, this is very important. With YAML files, spacing matters. Okay, so we're going under services, and we're going to provide a list of all the different services that we want. So I want you to hit tab just once. And then here we're going to provide our container, or our first container. In our example, we just have one container, which is our Node app. And we want to give this container a specific name. You can call it whatever you want. We can say like, oh, my Node app, or we can call this Node project, whatever you want. Just give it a name. I'm going to call this Node app because that's what it is. And then colon, and then we're going to add in specific configuration settings for that container. So because we're going to do configurations for that container, I want you to hit one tab, and then I want you to start adding in the different configuration settings. So the spacing matters, unfortunately. So if I start moving things around, it's going to break things. So you want to do one space for each level. And keep in mind, if you have multiple containers, let's say you have a Postgres container, you would add a Postgres service. If you had a Redis service, you'd add one here. So this is how you add more containers or more services within a Docker Compose file. We just have one, so I'm going to delete these. Now, under Node-app, we have to specify a build setting. So what image are we going to use? Well, we have to build the current Docker file in our current directory. So we can say build, right? And then we pass in the path to our Docker file. So it's going to be our current directory, or whatever directory this Docker Compose file is. So this is just automating the Docker build command so that we don't actually have to do it. Docker Compose will do it for us. We just have to pass in the path to the Docker file. A couple other settings. Let me actually just hit the up arrow keys to see all of the different options that we have. So we do need to expose a port. So let's open up a port so we can pass in the ports option. So under ports, one tab, remember. And here we can provide a list of ports we want to open. So for our container, we've only been opening up one port, but theoretically you can open up as many ports as you want. You do a dash because it's going to be a list of ports. And then here we're just going to do 3000:3000. You already know what that means. I'm not going to rehash that. If you wanted to add another port, or open up another port, you can do that. So you can do like 4000 colon 4000 as well, but we're just going to open up one port. So I'll delete that. Now I'm going to hit backspace again. So we're lined up with build and ports because once again, we're still under the Node app service. And here we want to pass in all of our volumes. So we'll do a volumes. And we're going to pass in our 2 volumes. And once again, this is going to be a list. So I want you to hit tab just once. And then we're going to pass in a dash. So the dash signifies a list. So the first one is going to be our bind mount. And the great part about this is that when you use a Docker Compose file, we can just do the dot syntax. We don't need to use this variables that I mentioned before. So we can just do // colon and then /app. And I think you can pass in RO if you want to be read only. I don't really care. Right. And then we need to pass in our anonymous volume, right? Which is this one right here. And that's that little hack that we did to make sure that we didn't overwrite our node modules folder. So we'll do /app/node_modules. And then last but not least, I'm going to add my environment variable. Doesn't really matter where you put it. So once again, line it up with build, ports, and volume. So we do environment. And we say dash. And then here, you provide a list of environment variables. So we can do port equals 3000. All right. Keep in mind, in this case, this would be like the equivalent of running the environment variables one at a time. So let me see if I can find an example. So like this. However, we can pass in a file like we did down here if you want, so that we can use the .env file. And the way to do that would be, let me see, you can go down here and we can say env_file colon, and then we can say dash, you can provide a list of files, and then the path to the .env file. So whichever syntax you prefer, I'm just going to comment this out. I'm just going to use this because we just have one environment variable, so there's no need to import it in from an environment variable file. All right, so let's hit save. This has all of the settings that we need for our Node app service. And once again, if you're building out a full-blown project, you're going to have multiple services. So you're going to see how this kind of really simplifies the entire process of getting your entire development set up and up and running, and as well as tearing it down all within one command. So make sure you save that. And what we want to do is we're going to run the command docker compose. So we do docker -compose. This is important, right? Don't do docker --compose. It's a different command. We want docker -compose. And then we want up. So that's going to bring up everything that's in our compose file. And then one important flag is if we do --help, let's see what options we have. We do have a -d flag, right? If you remember when we run our containers, we have to pass in the /d flag, or then we'll automatically attach to our containers, which we generally don't want. So we can pass in the same thing for our Docker Compose. So we can do Docker Compose up -d. So let's see if that works. So first thing you're seeing is that it's actually building our image. And so it's running, looks like I ran into, yep, that's just a warning. Don't worry about that. I think that's a new patch. So that's just a vulnerability message. Don't worry about that. So it built our image. If we do a docker image ls, you'll see that this is the image that it built. And notice the naming convention. What it does is it grabs the project directory, which I called node-docker, and then it passes underscore and then node/app. So the node/app is from the service name. So it took the project folder, did underscore, and then the service name. If we had one for Postgres, it'd be underscore Postgres or whatever we called it. All right, so it built the image, and then it also started our container. So if we do a docker ps, right, you can now see that we have one container running. And it called it, once again, take a look at the name, node-docker, which is the project name, underscore, then the name of the service, and then there's an _1. I think if you have multiple, if you spin up multiple Node app services, I think it goes like 1, 2, and 3. I think that's why the 1 gets appended. But let's test this out. Let's just see if everything works. So going back here, if I hit refresh, looks like it works. And let's change our code. And delete the exclamation points just to make sure it updates. Hopefully it works. And it looks like that, guys. Everything works perfectly. So hopefully you guys can see how easy it is now to actually bring up our entire Docker environment with just one simple command. And bringing it up is just as easy as bringing it down. So now if you want to tear down everything, we can do, let's see, we just do docker-compose instead of up. I'm sure you can guess what the command is. It's just down. And just like when it comes to deleting Docker containers, by default, it will not delete those anonymous volumes. So if you want to delete the anonymous volumes with the Docker compose down, we can do a -v, and that's going to delete all the unnecessary volumes that it creates. So we'll do -v. And you can see it's stopping the Docker container. It's then removing it. Technically, when you run Docker Compose, it creates a brand new network for all of your services. Don't worry about that. It's kind of outside of the scope of this video, but it does automatically create its own separate network so that it doesn't interfere with any of your other Docker containers. And you do get some extra features and perks when it comes to having a custom network like DNS so that you can reference names within your project. But don't worry about that for now. So now if we do a Docker PS, you can see that the container is deleted and everything's cleaned up for you. That's right, one command and you can start and stop theoretically hundreds of containers, right? Now, there is one thing I want to tell you guys. When we run the Docker compose up command again, what do you think is going to happen, right? Because if you take a look at the steps that took place when we ran it the first time, you can see it builds the image, right? It builds the image and then it starts the container. Now, if we run this again, I want you to tell me what you think is going to happen, right? Your natural guess is going to be that it's going to build the image again, and then it's going to run the container. Well, let's figure that out. Let's see what actually happens. If I run it again, look at this. The result was much quicker, and that's because it skipped the entire build process. It didn't build a brand new image. All it did was it created the network. I did tell you it created a network, and then it started our container. And the reason for that is that what Docker Compose does is it looks for an image. So if I do Docker image ls, it looks for an image based off of the syntax that I told you, which is project directory, and then the name of the service. And if it sees that that image already exists, it's not going to rebuild it. However, even if we make a change, right? Let's say we change the default port to be 4000. Oops. Right? This theoretically is now a different. It's a different image, right? We've changed something fundamentally in the Dockerfile, so it should rebuild the image if we run it again. So let me tear it down again. Let's do a Docker compose down. All right, and I think I saved it. I can never remember if I do that. And let's do a Docker compose up. So let's see if it rebuilds the image. And despite the fact that we made changes, it did not rebuild the image. So now we're essentially running a stale image, right? Why is it doing that? Like I said, there's just a simple dumb check that Docker Compose does. All it does is just look for an image named this. So if we do Docker image ls, we can see there's an image there. It has no idea that this is a stale image and that there's been an update. It doesn't know. Docker Compose is pretty dumb. It has no idea. So you have to basically tell it like, listen, I've made a change. I want you to rebuild the image. So how do we do that? Well, first of all, let me tear things down again. And let's go back to the Docker compose up command and let's do a --help. And there should be an option that causes it to force a build. And let me see if I can find it. Here we go, --build. So this, when you run the --build flag, it's going to tell Docker Compose to rebuild the image. Docker Compose is not smart. It does not know when it needs to rebuild the image. You need to tell it to. All right, so let's rerun this again. We'll do Docker Compose up -d --build. This will force a brand new build. And there you go. So now we built a new image. Now it created everything, and everything should be working now. All right, so we can tear that back down. We can tear that back down. Change the default port to 3000. Save that, just so that we don't break anything else. And then if you want to, you can rebuild it again with the --build flag. And so this will bring everything back up. and rebuild it with the new default port. And everything should be working. So let's just double check. And yeah, everything's working. Perfect. But that's the idea behind Docker Compose. There's nothing too fancy about it. Obviously, you're going to have to take a look at the documentation to see other things, because eventually when you get a little bit more familiar with Docker and there's other settings or options or flags that you want to pass in, you're going to have to update the Docker Compose file to take in those parameters. So I just covered the basic parameters, but there's obviously plenty more within the Docker universe. Now, we're almost done. However, there's kind of one last thing. This is kind of a big thing, but you may have noticed that we're running npm run dev, right? So how do we actually go into production, right? Because right now when we run Docker Compose, everything is with respect to our development environment, because our Docker Compose, it creates that bind mount, which we would never want in production deployment, right? We don't need it to sync with anything. It's our production deployment, right? And our production deployment might actually use a different variable or a different port that Express listens on, or it could use the same one. I don't actually know. It's going to depend on your company or how you set up your project. But mainly also within our Dockerfile, it's not going to run npm run dev. Instead, it's going to run either, where's my package.json? It's going to run an npm start, or we can just run node index.js directly. So in the next section, I'm going to show you guys how we can set up our Docker Compose file so that we can have a separate set of commands for production and a separate set of commands for development. All right, guys, so this is going to be the last section of the video, and this is going to just round out the entire project. I'm going to show you guys how you can set it up so that you can deploy your Docker containers to both a development environment as well as a production environment, because there are going to be some differences between those two environments. And the easiest solution is, you can obviously have a separate, you can create multiple Docker files. There's no rule against it. So you can have one Docker file for development, one Docker file for production, and then you can basically change out what you want. So really the main change in our case is just the final command that we run, npm run dev for development and npm start or node index.js for production, depending on which one you want to use. If you read online, some people recommend not using the npm command within container because it's just another layer between node and the container. So a lot of the times for production especially, you might want to just run node index.js instead of running npm start. But I think different people have different opinions on that. So we can create different Docker files. And on top of that, we can also create different Docker Compose files. So you could have one for production and you can have one for development. There's also differing opinions on that. Some people like to condense as much into a single file and be able to kind of run both of them off of one file, but it really comes down to personal preference. So what I'm going to do is I'm going to show you guys how to do everything as much in one file as possible. So we're going to use only one Docker file, but we are going to split up the Docker Compose files into two different files. Because showing you how to do it with two different Docker files, it's pretty easy, right? You just create two different Docker files and then reference them when you actually run the build command. So there's nothing really to that, but I do want to show you how to do it with one file, just in case you want to know that, because it was a little bit trickier. We do create like a custom bash script that actually handles that. So let me walk you through that. So what we're going to do is I'm going to rename this Docker Compose file just so that we have this for reference, but we're not going to use this anymore. I'm just going to rename it as backup or something, dockercompose.backup.yaml. And we're going to create a brand new Docker file, a brand new Docker Compose file. And on top of that, I'm going to create two more files. So let's do a new file. I'm going to call this one docker-compose.dev.yaml. So this is going to have the configuration specifically for our development environment. And then we're going to create one more. And I'm going to call this docker-compose.prod.yaml. So this is going to have all the configurations specific to our production environment. And remember, we're just going to have one Docker file. All right, so we have three Docker Compose files. And obviously, if you have like a staging environment, you can also create another one for that. Sorry, these are the three. This is the backup just for reference if you guys want to take a look at that later. But these are the three. So the Docker Compose file now is going to have any configurations that are shared between both environments. And what I mean by that is that, like I said, in an actual project, you're going to have 6, 7, 10. You might have a ton of containers. So you'll see that a lot of the configurations for your containers are going to be the same regardless of environment. So there's no point in us copying and repeating all of those configurations across both of these files. We're going to create a shared one for all the configs that will be shared between both environments. So what I'm going to do is, I'm going to do the same thing. We're going to set the version like we normally do. And then here, services, we've got our Node-app. And I forgot to add that tab. Remember, spaces matter in YAML. Right? And we're going to set the build to be the current directory like we did before. And then for my production and for my development environment, I'm just going to say they're both going to be listening on port 3000. However, keep in mind that maybe in your environment, they're different. So if they're different, you don't want to put in this file because this file is only for when things are the same between your production and your development. If they're different, you're going to want to put them in their respective files. This is only for shared configurations where they're the same in both environments. So ports, we'll set that equal to 3000 colon 3000 like we always have. And then we'll also set an environment variable to be port 3000. All right, so this is the only configuration that's shared between both. All right, so our development. So in our development, our production environment, basically we're saying that the final image is going to be the same, ultimately, that we build from our Dockerfile, because both the environments are going to use the same Dockerfile. The ports are going to be shared, so we're going to use port 3000, and this environment variable that we're setting is going to be shared between both environments. All right, so now within our dev and our prod file, we can actually go into our services, create a Node app section, and then overwrite anything that we wanted to. So we could technically overwrite the ports, we can add in extra configurations, and so on. So let's go to our dev environment. And I'm actually going to go back to this, and I'm just going to copy up to Node app because it's going to be the same. So we go into our dev and our Node app, and I'm going to set the volumes, right? Because in our development environment, we want our bind mounts, as well as the extra anonymous volume for making sure our node modules folder doesn't get deleted. So I'll do volume. And we're going to do / actually, why waste my time retyping that? We can just copy this from here. You just got to make sure the spacing's okay. Don't mess up the spacings. And I think I messed it up. Hold on, let's see. So yeah, 1 tab. And 1 tab. There we go. All right. And since this is our development environment, we're going to pass in an environment variable. Did I spell that right? That does not look right. There we go. And we'll say node_env. So this is just common across Node applications where in your development environment, you're just going to set this to development, and then in your production, you would set it up. You would set it equal to production. All right, and then the final thing is, in our Dockerfile, I'm going to change this to default to. It doesn't really matter what we set here because we're going to overwrite it. So I'll just set this to either npm start or node index.js, whatever you prefer. I'm just going to set this to index.js by default. And remember, we can override any of this in our Docker compose file. So in here, we can override that command with the command option. And we can say npm. Well, we do this on the same line. npm run dev, right? Because we have that script that's going to run nodemon so that it restarts our code in our development environment. Let's save that, or save everything. And now let's move on to our compose prod file, but copy the first 3 lines as usual. Now in our prod file, what do we need to exactly change? Well, let's take a look. We don't, in our development environment, we had our volumes. We don't actually need these. The only thing I can think of is we need to change the environment variable to be production. And we need to change the command to be either node index.js or npm start. depending on what you prefer. So let's add those in. So we'll do environment. And then we'll do node_env equals production. And then our command is going to be set to node index.js. Once again, you can do npm start, whatever you prefer. So that's pretty much what we need. So let's test this out. I'm assuming I've probably put in a couple of typos, so we're probably going to have to do a little bit of debugging. All right, so what we want to do is the command's going to be a little different. So first of all, do I have anything running? Yeah, I do. So let's do a docker compose down -v to delete everything. So docker ps, docker images. Oops. All right, so now how do we actually run this now that we are going to have to run 2 Docker Compose files, right? Because when we want to run in production, we're going to do the base Docker Compose plus the dev. And then when we want to work in production, we do the base plus the prod. Well, what we have to do is you do docker-compose, and then you pass in the -f flag for file. And this is important. The order actually does matter. So the first file that we want to pass in is the base file. So we do docker-compose, compose.yaml. Then we pass in the -f flag again to specify the second file. So if we want to go into development, we're going to pass in the docker-compose.dev.yaml. Right? And so what's going to happen is it's going to load all the configuration from the base file, and then it's going to load all the configuration from the dev file, and then if it needs to, it'll overwrite any of the configurations that it's been set to from the base, and that's why we pass it in that order. Right? And then we want to say we want to bring it up, and then remember we want to run it in detached mode. So let's test this out. Hopefully this works. What did I mess up? Docker dev.yaml. What did I mess up? Must be a mapping, not an array. Let's see. Oh yeah. Look, I mean, you can see I already messed the indentation. The volume, environment, and command need to be under the node app section. So that's what broke. So let's tab everything up one section. And now let's give that a shot. All right, looks like things are working. So hopefully, yep, everything looks good. So let's just do a docker ps, and we see our container running. Let's go to our application. Let's hit refresh. It looks like it's working. Let's just go to our code, make a few changes to make sure that things are updating and that NodeMon's doing its job. So let's hit save. Let's go back, hit refresh. Look at that. So this is our development environment, and it looks like everything's working perfectly. And we can go ahead and shut that down. So we'll do, remember, same thing, we do down, and we can pass in the -v flag so we can delete those extra volumes. And it should stop it. Now let's do the same thing. We'll run that same up command, but instead of running docker compose.dev, let's try the prod version now. All right, and it should be the same exact command outside of specifying the prod.yaml file. So we hit enter. Perfect. Let's hit refresh. All right, so there's no exclamation. That's just because we didn't rebuild the image, but we'll go over that. But let's just try to change things. Well, I guess there's no exclamation at the moment, so let's hit save. And let's see if it changes. And it looks like it doesn't, which is perfect. All right, we don't want any changes. If we add anything else here, and then hit save. Remember, we're in production, so there is no bind mount, and we shouldn't see any changes. Now, just to make sure things are working, I'm going to bring this down. We're going to do a down -v. And just like before, right, when we make changes to anything, like our source code or anything else, since we're in production environment and there's no bind mount, anytime we make changes to our code, we're going to have to rebuild our image. And we have to tell Docker Compose that we want to rebuild it. So we'll do up. So right now it's got all this nonsense in there. So we do up, -d, and then I think it's --build. It's going to force a new build, right? Because now we're changing our code. There's no bind mount. And so to actually see the update, we have to rebuild the image, right? And so now if I hit refresh, we see all of that nonsense. And just as a double check, let's delete the exclamations and let's delete all that nonsense right there. Hit save. Do we see any changes? Absolutely not, because remember, we are in production environment. So this confirms that we now have set up different Docker Compose file for our production environment and for our development environment to accommodate our specific needs for each environment. Now, there is one last thing we got to do because there's a little bit of an issue, and I'll show you why. Right now, what was the last command? We're running in production mode, right? So we ran the docker compose.prod, and I'm going to do a Docker PS. Let's just quickly get the name of that Docker image. And I'm going to connect to this Docker container. So we'll do docker exec-it, and I'm going to copy that name, and then we'll do bash. All right, so here, what I'm going to do is, well, first of all, you'll notice that we copied a whole bunch of Docker Compose files. And that's because in our Dockerignore, they're not in there. So we can add those in there as well. And we can just say docker-compose star. And that'll just ensure we don't copy anything or any file that starts with a docker-compose. So this is kind of a wildcard for matching anything after that. So we'll hit save on that. But that wasn't really the main thing I wanted to address, actually. So if we go into our node modules folder, this is kind of important. If I do an ls, this is going to show you all of the dependencies that we have, all the packages. And there's something very important. If you look at this, you can see that nodemon is installed. And you might be wondering, why is that an issue? And I want you to remember, we are in production mode, right? And in our package.json, we can clearly see that nodemon is a dev dependency. We don't need this when we run into production mode because we're never going to be using nodemon in production. That's only for development so that it automatically restarts the node process when we are developing our project. So how do we actually prevent nodemon and any other development dependency from getting installed? Because right now it's just taking up space and doing absolutely nothing. Well, in our Dockerfile, you can see that we run an npm install. If you want to actually deploy this to production, right, you would normally run I think it's a -- only equals production, right? And so that'll prevent any dev dependencies from getting installed because you're running in production mode. So what we have to do now is set up our Dockerfile to be intelligent enough to know whether we are in development mode or production mode, and then either run an npm install or an npm install -- only equals production, depending on if we are in our development or if we're in our production environment. So how exactly do we do that? Well, we're going to have to basically write an embedded bash script. So here, instead of this line right here, what we're going to do is I'm just going to go under here, and we're going to replace it with this. I'm going to say run, and we're going to do an if statement. And we're going to say if, and then we're going to do brackets. And this is important. Make sure you hit one space. All right, this gave me all sorts of issues. You want to make sure you put that space. And then in quotations, we'll do $node_env. And then that equals development. Right, and this is also important. Hit one space afterwards. I don't know why it required that, but it did. And I was troubleshooting that for a while, so make sure you get the spaces just right. So what we're saying is, if we are in a development environment, then we want to run an npm install. However, we're going to do an else if we're not in development, so we're in production, we're going to do npm install -- only equals production. All right, and then we end that if statement. And we no longer need this run command. Okay, so basically, we're referencing some kind of variable here called node.env. And then when it's set to development, we'll do an npm install, or else we'll do an npm install with -- only equals production. Now, what exactly is this? Well, this is an argument that we have to pass in. So here we do arg node_env. So this is an argument that gets passed into our Docker file when it's building the Docker image. And we have to set this value in our Docker Compose file. So under dockercompose.dev and .prod, we're going to have to pass that in. So going to the .dev file, we are going to actually overwrite something in our base Docker Compose file. So instead of doing just build that, we're going to have to change this up a little bit. So here, when we do the build command, we're going to override that. And instead of just doing instead of just doing colon dot, we can actually break this down into a few more settings. We can do build colon and then pass in two properties. We've got the context and then we've got the args. Now the context, remember when we did build dot, and that's just specifying the location of the Docker file? That's what the context is. So here we just specify the location of the Docker file, which is in the same directory. So we just pass in dot once again. And then here under args, we pass in all the different arguments that we want to pass. So here, the only thing we care about, right, is the one that this Docker file is using, and it's called node_env. So we do node_env. I'm going to set this to development because we're in the development Docker compose file. And we're going to copy this, and I'm going to do the same exact thing in my prod file. And we're going to space that. There we go. I think that should be good. Yep. And we're just going to change this to production. And let's save everything. And let's just do, I'm going to bring this down. All right, and let's just make sure we save everything again. All right, so now it should theoretically, run this if statement when we want to do an npm install, and it should be able to detect depending on what the arguments that's passed in. So we're going to run in development mode first, just to make sure everything's working, and then we're going to run it in production mode after that, just to make sure that that actually made the changes that we wanted. So let's go back to my up command. We're going to start off with dev. All right, so it's building that. Remember, I told it, I passed in the -- build flag because we made changes, and Docker Compose is not intelligent, and it will not know that we need to actually rebuild it. So I always pass in the - build flag in that scenario. And let's test this out. So hit refresh, it just says hi there, which is fine. When we go to our index.js, let's add some exclamation points, hit save, refresh, perfect. So just the fact that it restarted automatically and it adopted those changes, we know that NodeMon was successfully installed. And so we know that that if statement so far, right here, it ran an npm install because it detected that we were in development mode. So far, everything's looking good. Let's bring everything down. With the -v flag, let's delete that volume. And this time, we're going to bring it back up, but I'm going to do it in prod. All right, and let's just do a docker ps. Let's just make sure everything's running. Perfect. Let's hit refresh. Perfect. Let me make changes to this code real quick just to make sure it doesn't adopt those changes. So we'll hit save. Let's hit refresh. No changes. Perfect. The last thing that we want to do is let's log into the container and let's just make sure it did not install NodeMon, just to ensure that it did successfully run the -- only production flag. So we'll do docker exec -it. And then bash. Right, ls, let's go into node modules. Also notice how our Dockerignore file worked this time because it did not import any of the Docker compose files. But let's go into the node modules folder. Let's do an ls. Do you guys see anything with NodeMon? It should be alphabetical. Let's do it. All right, so if we go to m, n, see, nothing with NodeMon. So it successfully is in production mode. And if you do a print nv, we can see that I would have thought we would have set Node.env set to production too. So everything looks like it's working. It successfully only installed all of our production dependencies. And so guys, that's all I wanted to show you. It's just a matter of two commands. Whoops. Well, it looks like we're not actually going to get out of the container, but it's just two commands, right? So you do docker compose up, docker compose down, and And then if you're in production, you pass in the prod. If you're in development, you pass in dev. That's all you have to do. You've got two different environments, and we can easily spin up all of our containers and then also spin them back down with just two simple commands. Up until now, we've only been working with one Docker container, and that is our Node container, which houses our Express application. However, what I want to do is I want to add a second container because this course is ultimately a Docker course. And I want to make sure that you guys are comfortable with adding in more than one container into your application. So what we're going to do is we're going to add a Mongo database to our application. This is going to make our app a little bit more of a real world type application because we'll finally be able to persist some data. So let's head on over to Dockerhub. And so here I already searched for MongoDB, but if I just search for again, you'll see that the official image is going to be the first result. So select that. And this is going to have all of the instructions for working with the MongoDB image. And if we head on over to Docker run example right here, we can see that the name of the image is just Mongo. So we can do Mongo and then the specific tag or version that we're looking for. So let's go to our Docker Compose file and let's add in this new Mongo database. And so first of all, we have to figure out where we need to add it inside this Docker Compose file. And so if you already forgot, under services, this is where we actually define all of our containers. So each container is a different service. So we have one service called Node app, which is our Node container. So logically, if you want to add a MongoDB container, we're just going to create a new service. So let's go here. I'm going to do, make sure it's just one tab from the base. Oh, not one. There you go. So it's lined up with the Node-app. And let's create our Mongo container. So first of all, we have to name our service. We can call it anything we want. We can call it database. We can call it Mongo. We can call it whatever we want. I'm just going to call it Mongo because it makes sense. It doesn't have to be, though. I just want to make sure you guys understand that. The service is just for your reference. And you'll see here that we have a the build argument. And so in our Node app, right, we're actually building our own custom image. We're taking the base Node image and then we're copying our code into it. However, for the Mongo service, right, we're just going to use this built-in image. This has everything we need. We don't need to customize it. So anytime you're just using another image, we can use the image property. So we call image, and then we call in the name Mongo. So that's going to grab this specific image. And I don't really care about the version. Any version's fine. So I'm just going to grab whatever the latest is. And then in the documentation, it's going to show us that we have to pass in some environment variables. And so you can see here, looks like, where is it? It's going to be somewhere down here. Here we go. So these are the two variables, the environment variables that we have to pass in to make sure our Mongo container works properly. So we have to provide the root username and the root password. So I'm going to copy these. And feel free to set it to whatever you want. I'm just going to call this Sanjeev. And then let's grab the password as well. And I'm just going to say my password. So let's save this. And then let's do a Docker Compose up. We don't need to do a -- build. All right, so now we can see that it is now creating our Mongo container. And if I do a Docker PS, we should now see two containers. We have our Node Docker Mongo container as well as our Node app as well. So now that we have our Mongo container up and running, what I want to do is I want to connect into the container and just poke around a bit. So let's do a Docker exec -it and then the name of the container. And then we'll do bash. So we can take a look at the file system. And so here, since we're connected to the container, we can actually connect into Mongo. So if I type in Mongo, and then we got to pass in a couple of flags. That's going to be for your user and password. So if I do -u, you pass in your username. And so that's going to come from that environment variable that you set. And then we have to pass in -p for the password. And so now we're logged into our Mongo instance. And I want to run just a couple of Mongo commands. If we type in db, this is going to show us what database we're connected to. And so right now we're connected into a test database. I guess Mongo creates a test database so that we have some database to log into. And we can create a brand new database with the use command. So if I type in use and then the name of my new database, so I'm just going to call this mydb. You can see that it's switched to our newly created database. And we can run the command show DBs to list all the databases. And you can see that mydb is not listed on here. And that's just because Mongo won't list this database until we have a document or an entry within that database. And that would probably explain why we don't see test in that list as well. So let's create an entry. And let's just say we're making like an application, like a library type application that's going to store a list of books. So we can do DB, then the name of the collection, which is called books. And then we'll just do an insert. So here we have to pass in the properties of that entry. So we'll say name is going to be Harry Potter. All right, and so this means we successfully wrote to our database. And if I type in db.books.find, this is going to list out all of the documents within our books collection. So here we've got one entry, and we can see the name is set to Harry Potter. Perfect. And if I do a show DBs now, we can see my DB is now listed on there. So let me log out of here. And I do want to show you guys one thing real quick. So if you remember, if your goal is to get into the Mongo shell or the Mongo CLI, instead of having to do a docker exec it and then bash and then run, where is this command? Mongo-u. Instead, what we can do is we can skip the bash and just run Mongo-u, then the username, and then the password. All right, so just a quicker way to get there. But now what I want to do is I want to tear down our container. So let's do a Docker compose down. And I'm going to use the -v like we've been doing to make sure that we delete that anonymous volume. And then I want to bring it up. And I know you're thinking like, well, why do we tear it down just to bring it back up? It's obviously so I can teach you guys something. So let's do up -d. And let's give it a few seconds to fully boot up. And then what I want to do is I'm going to log back into the Mongo shell. And let's do a show DBs, right? And right there, something looks odd, right? Our database that we created called mydb is now gone. And you might be wondering, well, what exactly happened? Well, think about it. We had a container, our Mongo container. We ran a Docker compose down, which then deletes the container. Then we ran a Docker compose up, which then creates a brand new container. So this is a brand new container. Everything that was in the previous container has been deleted. And this is a major problem because this is our database. You know, we don't want to lose that information. I mean, if you're doing, running like node tests and things like that, then yeah, maybe you'd want your database to kind of start from a fresh state each time. But, in a production environment and even in a development environment, we want to keep all of our database information so that we don't have to keep recreating those entries. And especially in a production environment, if you lost your database, that's all of your application data that's just gone, right? At that point, you've pretty much broken your website or whatever application you're building. So you don't ever want to lose that information. And so how do we actually save that information? And I'm sure you guys already know this, right? We use volumes. If you look at our Docker compose file, actually, let's go to the dev file. And for our Node app, you remember there's two different volumes here. So this helps us persist data. So let's do the same thing with our Mongo container. So let me exit out of here. And let's do a Docker compose down. And let's go to docker-compose.yaml. And let's add some volumes. And, if we go back to the dev, actually, to the .dev YAML, you'll see that there's two different volumes that we covered. We covered the bind mount, which syncs the data within the container to a folder on your local drive. And then we have an anonymous volume. So, we could theoretically use either one. If you wanted to be able to poke around on your database data on your local machine, then you'd use a bind mount. But however, I don't really care about looking at that data. I can just log into the Mongo client and actually just run commands to see what I need. I don't care about the file system. So it looks like anonymous volume is a better choice. However, here's the problem. If you have an anonymous volume, and I think I have a few left. So if I do Docker volume ls, right? These are what anonymous volumes are, right? Just a bunch of random numbers, just a random string or ID. I have no idea what these are for. And so when you have an anonymous volume, there's a good chance that you may accidentally delete it. And so I don't feel comfortable using an anonymous volume for this scenario because this is our application data, right? I want to make sure I know which volume is storing that data. So what we can do is we can create a named volume. Named volume is exactly the same as an anonymous volume, except we can give it a human readable name. So let me show you guys how to do that. And let's go under our Mongo service. And let's create a volume. And so here, just like an anonymous volume, we have to pass in a path within our container. And so to get that information, we have to look at the docs. And let's take a look. So here we go. It's probably under this where to store data. And so you can see they created a volume. And here they used a bind mount, so they stored it on their local directory and they synced it with /data/db. So this is the folder in the container that we're interested in. So we want to do /data/db. And at this point, this is a anonymous volume. To convert this to a named volume, all we have to do is just do a colon and then just give it a name. So I'm going to call this Mongo-db. So it's going to save this volume with the name of Mongo-db. Right? And just to show you the difference, right? A bind mount, you provide a path on your local machine to a path on the container. An anonymous volume, you just provide a path to the container directory that you're interested in. And then for a named volume, you do a name, colon, and then the path within the container. But there's one more gotcha. Actually, let's save this and I'll show you what happens if we try to run this as is. So let's do a Docker compose up. Right, and it says, named volume is used in a service Mongo, but no declaration was found in the volume section. Right, so it's saying that we have to declare something. And when it comes to named volumes, we do have to declare this volume in another portion of our compose, in our Docker compose file. And that's because a named volume can be used by multiple services. So, if we had a, like another Mongo instance or another Mongo service or any other service, they can attach to the same exact volume just like this Mongo service does. So all we have to do is at the bottom, we just provide volumes. And so here we just provide a list of all of our named volumes. So here we just call this Mongo-db. That's all you have to do. Now let's do a Docker compose up. And let's connect into our Mongo client. Right. Remember, everything's gone. So let's create a new database and let's just insert that same exact entry. All right, perfect. So now let's exit out of here and let's tear down our all of our containers with a Docker compose down, and let's bring it back up and let's just verify that our information saved. So let's do a Docker compose down. Now this is where we run into another issue, and that's why I wanted to show you guys this. So remember, we're using this -v volume, this -v flag, to automatically delete this anonymous volume. Because we don't need it. It's just there for that one little workaround for our Node application. However, the problem is that this will delete not only anonymous volumes, but also named volumes. So if we pass in this -v flag, it's going to also delete this database, our Mongo database, a volume. And so we obviously don't want to do that because we just went through all of this hassle so that we could save our database data. So we unfortunately cannot use the -v flag anymore. So what you're going to have to do is remove the -v flag, and just do it down. And after that finishes running, if you do a Docker volume ls is going to list out all of your volumes. You can see we have our node docker MongoDB volume. So you can see it's given a nice name. So we know exactly what this is being used for. But we've got all of these anonymous volumes. So you'll see over time they start to build up. And you just have to delete them yourselves. And so there's a nice easy command called docker volume, I believe prune, but don't run it yet. Instead, what I recommend that you do is start up your containers. So bring this back up. And then do a docker volume. And then do a -- help. And so we have this prune command, which removes all unused local volumes. So all of the volumes that are being used right now by the running containers will not get deleted when we run the prune, only the ones we don't need. So as long as you start up your application, then your MongoDB and then whatever anonymous volume is associated with your application at the moment will not get deleted, and we can just clean up all the rest of the data that we don't care about. So if I do a docker volume prune, we should be good to go. And so now if I do a docker volume ls, you'll see we've got significantly fewer volumes. These are just the ones being used by either running or stopped containers. So just make sure you, I believe you should start your containers, but I could be wrong. Maybe it also saves stopped containers as well. So you might want to double check on that within the documentation. But I do want to highlight, just make sure that you only delete stuff that you don't need. All right, so now let's do a Docker PS. We have our Mongo container, and let's connect into that container again. And let's just do show DBs, and we can see that our data is still there. And if I do a db.books.find, oh, I forgot to switch databases, so we have to use MyDB. And then now we do this, and there we go. So we've now got persistent data for our Mongo database. So now that our Mongo database is up and running, let's set up our Express application to connect to our Mongo database. And when it comes to interacting with our Mongo database, we're going to use a library called Mongoose. So it's going to make it a little bit easier to talk to our Mongo database. And so here, if we pull up the documentation for Mongoose, we can see to install it, we just do npm install mongoose. So let's do that right now. All right, and so once that's done, first of all, we installed a new package. So we have to tear everything down. Remember, no more -v because we have our database. So let's do down. And then let's do an up again. And we want a -- build. All right, and now going back to the documentation, the first thing we have to do is we have to import Mongoose. So let's copy that line. We'll paste that in there. And then we have to connect to our database. So here we just call the mongoose.connect method. And then we have to pass in our URL as well as some config options. And so the full URL, if you pull up the actual Mongoose documentation, it's going to look something like this. We do MongoDB, and then :// then your username, your password, the IP address of the host, the port, and then some options as well. So under here, we'll do mongoose.connect, MongoDB, // and then here you pass in your username. So mine's Sanjeev, and then the password's going to be my password and then here we have to give the IP address. Right? And so this is probably where most of you guys are going to get stuck, because we have to figure out, what is our IP address? How does IP addressing work with Docker containers? Well, here's the thing. Docker makes it really easy to work with containers, and it automatically assigns your containers an IP address. So if you ever want to figure out what the IP address of a container is, first of all, do a Docker PS, get all your Docker containers that are running, and then here you can do a Docker network, Docker inspect. So this is going to give us more detailed information about a container, and we can grab our container name. So here I'm just going to grab our Node app first, just to take a look. And so here you're going to get a ton of information. And if we go all the way to the top, let's take a look at what's up there. A lot of random information that we don't really care about. And I believe what we're interested in is going to be all the way at the bottom. So let's scroll on down to the bottom. And here there's a section called network settings. So this is probably where we want to look. And so if we keep going down, you can see there's something called networks. And so there's a concept within Docker called networks, where you can create more than one network and then put different containers within those networks so that only the containers within a network can talk to one another and they can't talk to containers in other networks. So it looks like there's a container called node docker _default. So, this represents our directory name. So this looks like it was created by Docker Compose, and it actually was. So Docker Compose does create a brand new network just for your application so that all of the containers and services within your Docker Compose file will get placed into that network. And you'll see here, we have an IP address. So this is the IP address of our node application. And then here you can see its default gateway. And so we want to grab the IP address of our Mongo container. So let's do the same thing for our Mongo container. And let's do a docker inspect and then grab the name of our Mongo container. Once again, it's using that same exact network that was created. And we can see here, this is the 172.25.0.2. So this is the IP address. And I'm just going to copy that. We can paste it in here. And then we want to put the port that's going to run on, that Mongo's running on. So it's going to be running on the default port, as long as you didn't change any of the default configs. So 27017. And then we're going to pass this one property auth source equals admin. All right, let's save that. And then here we're going to call .then. So here we're going to pass in an error function, and we're just going to say if we successfully connect to our database, I just want to do a console.log, and we'll just say successfully connected to database. And if this failed, we'll just do a .catch, and we'll say, first of all, we'll pass in the error, and we'll just console.log error. All right, let's save that, and let's see what happens. So if we do a docker ps, and then we're going to do a docker logs, and we'll connect to that node application. So here we can see that it said successfully connected to database. So it looks like we've successfully connected to the database and everything's working. However, there's something I don't like. Right now, we had to go into Docker inspect to get the IP address of our container and then put it into our code. However, if we stop and start our containers, or if we do a Docker Compose down and then back up, right? First of all, there's no guarantee that we get the same IP address. And even if we could guarantee the same exact IP address, the first time we run it, we'd have to go in, we'd have to get the IP address and then update our code. And that's just a really sloppy way of doing things. And so Docker actually has a nice feature that allows us to make it easy to talk between containers. Right, and this feature only exists when it comes to custom networks that get created. So if I do a Docker network ls, you'll see there's a couple of networks that we have. We've got the bridge and host network. So these are the two default networks that come bundled with Docker. And then I've got a couple other ones. You may not have these, but you'll see that we have one for our node Docker default. So this is the one Docker Compose created. This is the custom one that created just for our application. And when you have a custom network, this only happens with the custom networks, the ones that you create, and not one of the two default ones. When you have a custom network, we have DNS. So when one Docker container wants to talk to another Docker container, we can use the name of that container or the name of that service to talk to that container. And so if we go back to our docker-compose file, you'll see that the service for my Node app is called Node app, and the service for my Mongo container is called Mongo. So I can refer to this container's IP address based off of this service name. So if I call Mongo within my Node app, it's going to automatically grab the IP address of our Mongo container. So if I go back to our index.js, I can change this to Mongo. And then here, if we do a Docker logs, and let me just do a pass in a -f. I think it's -f for follow. Actually, let me just do a help real quick. -f follow. And here, if I save this, you can see we still successfully connected to the database. So because of DNS, we're able to resolve this name, this host name, to be, whatever our Mongo container is. And just to show you guys exactly how that works, let's actually log into my Node application container. So if I do docker exec, actually, first of all, do docker ps, and we'll do docker exec -it. And then here we'll drop into bash. Let's ping Mongo. Let's see what happens. Look at that, right? It automatically uses DNS to resolve the name of Mongo, and it got the IP address of 172.25.0.2, which is our Mongo container. So that's how this whole DNS process works. So anytime you want one of your containers to talk to another container, all you have to do is refer to its service name, and it'll automatically be able to resolve it because DNS is built into Docker. And keep in mind, this is only applicable to networks that you create. It does not work with the default bridged network, okay? And if you want to take a look at your networks, we can actually do a Docker, first of all, we'll do a Docker network ls, and we can do a Docker network inspect. Well, first of all, I have to grab the specific network I want. So the one that's specifically my Docker Compose created, and then we can do inspect. And I messed up the order. Sorry about that. It's going to give us some more information about this specific network. So you can see here the subnet that all of our containers are going to use the 172.25/16. We can see what the default gateway is. And then we can see under the container section all of the containers we have. So we've got our Mongo container, and we can see the IP address as well as the MAC address of this container. And then we can also see the container for our Node application. And so this has also got an IP address and a MAC address. And I believe, and don't quote me on this, but it looks like, yeah, actually, that's all I wanted to show you guys from here. So I think that's going to wrap up this network section. So in the next section, we're going to make a few changes to our application so that it's a little bit easier to work with environment variables, and we can kind of store them all in this same area and section. All right, so one thing I don't like in our application is that, first of all, we're hard coding the URL into our application. You never want to do that. Instead, what I would rather do is have this URL stored as an environment variable. And so that way, when we move to production, there's nothing that we would need to change. We can just pull the environment variables that we set either in Docker Compose or on the host machine. So what I want to do is within our base directory, I'm going to create a new folder. And I'm going to call this config. And within here, I'm going to create a new file called config.js. So this is going to store basically a variable that holds all of our environment variables. And so here, I'm just going to do a module.exports equals. And then here, I'm going to store all of our environment variables. So if we go back to our URL, there's a couple of things we need to pull out of here. We need the username for our Mongo database, the password. We also need the IP address. We know with Docker, we can always use Mongo. So, whether you're in development or environment for the IP address, you can always use Mongo. So technically, we don't even need to save that as an environment variable. But, down the road, you definitely want to think about the future. There may be a time where you decide that, I don't want to keep my database as a Docker container. Maybe you want to use some kind of managed service. So in that case, we can no longer use DNS because it's no longer going to be running as a container. So if you ever do decide to maybe move your Mongo database to outside of the Docker world and then have it hosted by AWS or some other hosting platform or cloud platform, then you would need to pass in the IP address as an environment variable. So I like to just store everything as environment variables just so that we can plan for the future. So we need those three and the port, because who knows, right? The port could change in the future. So let's go back to our config.js. And I'm going to define a property called Mongo_IP. And then here, this is going to grab process.env.mongo_IP. So we're going to make sure that our Docker containers pass this environment variable in. However, if it's not set, then we're going to default to Mongo. Right? So that's what the double pipes mean. So if this is set, then we're going to use this value, and Mongo IP is going to be stored to the value of this environment variable. However, if this is not set, then this variable is going to be set to Mongo. right? And so the reason I'm doing that is because, we can always default to Mongo as our IP if we don't pass anything in. The next thing that I want to do is we'll grab the Mongo port. So I'll call this Mongo_port. And we'll say process.env.mongo_port. And then here, we're going to pass in the default value of 27017. Then we want the Mongo user. And we'll pass in the value of the environment variable of Mongo_user. And we don't need to default that. And then we need Mongo password. All right, so now just make sure that we're exporting it. And what I'm going to do is in our index.js file, we can then import those environment variables. So here, this is what I'm going to do is I'm going to change this to the template string, and then we can then grab those values. So here, this is going to be the username. So we'll just say $, and then we're going to grab in Mongo_user, right? And then make sure we let VS Code import it or manually do it yourself. Then the password, we want to do the same thing. Right. Then here, we also want to pass in the IP address. And then grab the port as well. Right. And make sure to let VS Code import all of these for you. And that should be about it. Technically, we could do the same thing right here for port. I just like to kind of have a config file right here that holds all of my environment variables so I can know exactly where to look if I ever need to change anything. And it's just kind of nice to have all of these in a central location. But, this section, this part of the video, completely optional. All right, let's save all. And then let's, so now that we saved it, let's go do a Docker logs. And it looks like we got an error. So what happened here? It looks like we got an authentication failed. So we clearly messed something up. Let's just make sure we save this. And right, it's failing because, well, first of all, we haven't passed in any of these environment variables. So we don't have a user or a password right now. So we have to pass that into Docker Compose. Okay. And so here right now, we've been using the base Docker Compose file for everything. And that's just because I just wanted to start off with something simple. But I think it's time we started kind of splitting things up between our dev and prod for Mongo. So right now, we're just working on our dev environment. So let's copy all of the Mongo related stuff that's for our dev environment and move it into the dev.yaml so that we're not cluttering up the shared configs. So for the environment variables, let's copy those. Actually, I can copy all of this for now and go into our dev. And then here, we can remove image because that's not going to change whether it's production or development. We'll set these environment variables. And then we also need to set the new ones as well. So what is this? Mongo_user. This is going to equal same thing as this in this case. And actually, I'm making a mistake. So this is going to go under our Node app, right? This is an environment variable for our Node application. We'll set that to Sanjeev. And then here we'll set this Mongo password equal to my password. And that's all we should need because the rest can default to what we're already using. So we don't need to pass those in. And then now I think we should still be tailing this. And we actually have to rebuild the containers because we passed the new environment variables. So let's stop this. And we're going to have to do a Docker Compose down. And let's bring it back up. And I realized it connected to the wrong container. We want our node application. All right, perfect. So now we can see we've successfully connected to the database. And once again, guys, this part of the video was purely optional, but I just kind of like having everything in a centralized location. And I just want to make sure that we kind of think about what our application is going to look like in the future and make sure that we can handle making any changes to where our Mongo database is actually stored. All right, if we take a look at the logs right here, you'll notice that we've got a couple of warning messages. So to clean up these Mongo warning messages, as well as maybe kind of clean up our index.js file, what I'm going to do is I'm going to actually store our URL into a variable. And so here I'm going to do const, and then we'll call this Mongo URL. And I'm just going to store this URL up here. And then in the connect method, I can just call Mongo URL. Then to get rid of those warning messages, I'm going to pass in a few properties. Don't worry too much about these. It's not really going to affect the functionality of our application. It's just going to make sure that we don't see those annoying warnings. All right, and so that's all the changes I wanted to make in this case. I just wanted to clean it up just a little bit. So let's save that. Let's make sure that we've successfully connected and we should be good to go. Now, when it comes to starting up our Docker containers, especially using Docker Compose, we can run into some potential issues. And that is when we spin up both our Node container as well as our Mongo container, we don't actually know the exact order that these will get spun up on. Right? Docker is just going to bring them up at the same time or relatively close to the same time. And that can lead to issues because if our node container spins up first, it's going to run this code right here to try and connect to our database. However, if our database is not up, it's going to throw an error and then crash our application. So we need a way to kind of tell Docker to load up our Mongo instance, our Mongo container first, so that we can ensure that when it's up and running, only then does our node container connect to it. And Docker Compose has a depends on field that we can use. So if we go into our dockercompose.yaml, we'll use the shared one in this case because we would want the same behavior, whether it's in our production or our development environment. And under our node app service, we'll say depends underscore on, and then we have to pass in the name of the service that we depend on. So we'll do slash or dash, and then the name of the service. So in this case, Mongo. And so what this is saying is that because our node app service depends on Mongo, we are going to start our Mongo container first. All right, so that kind of helps us. So let's tear everything down. And then let's bring everything back up. All right, now we can see that our Mongo container was started first and our node app was started second. And keep in mind, if you run this, enough times, you can confirm that it's always going to be the Mongo container first because it sees that our node app is dependent on our Mongo service. However, this still does not technically fix our issue because the only thing Docker does is it spins up this container first. It has no idea whether Mongo has fully initialized. It has no idea if the Mongo database is actually up and running. It just spins up the container. Right? It doesn't do any checks to verify that our Mongo database is up and listening for connections. So despite the fact that we have depends on, it doesn't necessarily solve our issue. It helps a little bit, but once again, our application, we could end up catching it where the Mongo container is up and running, but Mongo itself is still down and hasn't initialized, and our node app is ready to connect to it, right? And then at that point, our application crashes. And so ultimately, there's nothing Docker can really do in this case, or nothing specifically that Docker Compose can do. Maybe if you have an orchestrator, you can kind of work something out. But at the end of the day, you shouldn't rely on Docker or your orchestrator to handle that. Instead, you want to implement some sort of logic in your application to handle this scenario where your Mongo database isn't up and running before your application starts. And so usually that involves, if you try and connect and you're unable to connect to it, you want to keep retrying until you're able to successfully connect to it. Now, Mongoose in this case will actually try for 30 seconds automatically for you. After 30 seconds, you'll crash out. But for 30 seconds, it will just keep trying and trying and trying. And that's what we want. So it's great that Mongoose has this out of the box, but I just want to make sure that you guys understand that ultimately you need to implement some sort of logic in your applications to ensure that you can handle this scenario. And I'm going to show you as an example of something that you could do. And I'm not saying this is best practice. It most certainly is not. It's probably not the best way to handle this, but I just want to show you how we could somehow implement some sort of logic in our application to keep retrying until Mongo is up and running. So let's go back to our index.js. And what I'm going to do is I'm going to create a function. And I'm going to call this connect with retry. And I'm going to take this mongoose method right here. I'm going to drag it right into my function. And then under the catch section right here, I'm going to remove this. First of all, actually, I'll keep the console.log. I don't know why I removed that. But then if we error out for whatever reason, ideally we should check to see if it's because we could not connect to the server, but let's just assume because it's trying to connect that any error we get is because we couldn't connect to it. We'll say set timeout, and then we'll call this same exact function. So we'll do connect with retry, and then we'll just say after 5 seconds. So what's going to happen is we're going to call this function when we start our application, and then it's going to run. It's going to try and connect, and if we can't connect to it, what we'll do is we'll wait 5 seconds. So that's the purpose of the set timeout. We'll wait 5 seconds, and then we'll just call connect with retry. So we'll just call this function again, and then we'll try and connect. And then we'll do the same thing. We'll wait 5 seconds and just keep trying this. So this is going to loop forever until we can finally hit this then statement, right? Which is when we successfully connect to it, and then we can break out of this function. So that's just an example of how you would implement something within your application. I'm not saying it's best practice. I'm sure there's some negative aspect as to the way I've implemented this, and maybe it's not best practice. I'm just here to try and kind of sell home the point that you need to make sure your application handles the logic. Don't rely on an orchestrator. Don't rely on Docker or Docker Compose, because none of them can truly guarantee you that your Mongo database is fully up and running before your application starts. Make sure your application is intelligent enough to handle that scenario. And so the last thing that we got to do is we got to call that function. So here we just do connect with retry. Let's save that. And now to actually test this out, first of all, let's do a Docker. First of all, let's tear everything down. And now I'm going to show you a command that we have, or an option that we have with our Docker Compose up. So if we run up again with the -v, if we just run this like this, it's going to start all of our containers, all of our services. However, we can tell Docker Compose to only start up specific services. So in this case, we would want to bring up our just our node application. So if I do a --help, you can see at the top, we can just provide our service names. Where is it? I think it's somewhere here. It's listed somewhere here if you check it, but it'll list out, you can specify just the services you want to start. So if I do, and first of all, that shouldn't be -v, that should be -d, sorry. So here I can type in node-app, right? And so that's just coming from our service name. And so this should start just our node application. So if I hit that, we see a little bit of an issue, right? It started our Mongo container. So why exactly did it start our Mongo container? Well, that ultimately comes down to the fact that we use this depends on flag. So because this service depends on Mongo, right, it's going to start Mongo no matter what. So let's tear this back down, and I'll show you how we can start just our node application. Now here we do up -d and then node-app. And let's do a -- help. And let me do that before the name of our service. So here. And there should be a specific flag, and that is no deps right here. So that says don't start linked services, or it's basically saying you don't need to start the dependencies. So when we start up our Node application, despite the fact that we depend on Mongo, it will not start up any of our dependencies. So that's the exact flag that we want. So let's hit an up arrow, remove that, and then the -- I already forgot what it was. No deps. And then we want to call our service name, which is node-app. All right, so now it's going to start just our Node application. We do a Docker PS just to confirm. Perfect. And then let's do a Docker logs. And then we'll call this. And then -f. So let's take a look at our application and let's see what happens. And I can't remember if I did a save all. I mean, let's just do a save. There we go. Okay, so we can see that Mongo tried to connect, right? And it said connection timed out. All right. And so, by default, I think Mongo waits like 30 seconds again afterwards or something like that. So let's see if my for loop, actually it wasn't a for loop, but if my repeating function works. So we should ideally see the same exact error message when it tries to reconnect in a few seconds. And there we go. So I don't know if you guys saw that flash before you, but it spitted out the error once again. So this confirms that my application is continuously trying to connect to Mongo. So let's bring up our Mongo container now. So we can do a Docker compose up. And then here, we can remove all of these flags and just bring up our Mongo service. And so now if I run the Docker logs again for our Node application, when it tries to retry once again, it should then successfully connect. And there we go. So now we can see that we've successfully connected. And this confirms that our Node application is intelligent enough to handle a scenario where our Mongo database is not up and running at a specific moment in time. So it will just continuously retry over and over and over and over again until the database is finally up and running. So now that our Node application can successfully talk to our MongoDB instance, I think it's time we started to build out a demo CRUD application. And I was trying to think of what would be the best example project, and I realized that searching through YouTube, I could not find a single tutorial that covered how to build a to-do application. So that's exactly what we're going to build. Nah, I'm just kidding. I would never build the most annoying application. Instead, what I'm going to do is I'm going to build the second most annoying application, which is a blog application. So let's get started. Now, keep in mind, when we start building out the Express side of things, I'm going to move a little bit quickly just because I want to make sure this video focuses more on the Docker side of things. I'm going to expect you guys to have a little bit of background when it comes to Express already. So I'll move quickly. If you have trouble keeping up, I would recommend watching another tutorial on how Express works and then coming back to this. But I want to make sure that anybody watching this, whether they're interested in Express or Node, that they can follow along, because the idea behind all of this is all about the Docker side of things and how we can build a development to production workflow. So let's start off by creating a couple of folders. So the first folder we need is one for our models. This is going to store our Mongoose models. We'll create a new folder for our controllers as well. And we'll create a new folder for our routes. And so let's start off by building our models. And I'm going to create a new file, and we'll call this our post model. So this is a blog application, so we need something to represent our blog posts. And from here, we want to import Mongoose. And we'll do const post schema. And here, let's think about the properties we want to give it. So it's got to have a title. And we'll say this is going to be a type of string. And then we're going to say this is required. and we'll set that to be true. And if they don't include a title, we'll throw an error and say post must have title. The next property you should have would be a body. So this is going to be the content of the post. So once again, this is going to be a type of string. And we'll say required as well. And we'll say post must have body. All right, so this is going to be our blog model. Fairly straightforward. And then here, let's just make sure we export it. And now let's create our controllers so that we can handle creating, reading, updating, and deleting our posts. We'll call this post controller. And so first thing we want to do is we want to import our post model so that we can actually, interact with our database and create posts. And then we'll do export, and then we'll define our controller for retrieving all posts. So we'll do get all posts. And this is going to have a request, response, and next as well, although that's optional for a route. All right, and the way to retrieve all posts with Mongoose is we can just say const posts equals post.find. So that's going to connect to our database and retrieve all of our posts based off of this model. However, there's a couple of things we have to do. First of all, this is an asynchronous method, so we have to do async await. Sorry, that should be await. And then this function needs to be an asynchronous function. And then anytime you're working with anything that could potentially error out, we need to throw it in a try-catch block. So we'll do try. And I'm just going to move this into the try statement. And if it's successful, we want to make sure that we send a response. And we'll say status 200. And here we'll say, first of all, status of success. And we'll say results. Actually, we'll do data. And we'll just pass in posts. And then also, anytime we return an array of any kind, I usually like to include a results count. So we'll say posts.length. So however many posts we retrieve, we also return that as well. And then if there's an error, let's just send a status 400. Probably not the correct error code, but remember the point of this video is not about the Express side of things. I just need to get something up and running just to show you guys how all of this integrates together. And we'll say status, fail, and that's all. All right, so we've got the logic for retrieving all posts. Let's get the logic for retrieving an individual post. This is also going to be an asynchronous method. They're all going to be asynchronous. And I'm going to just copy and paste this, and we're going to just change a few things. But for the most part, all of this is going to be fairly similar. And then here, the only thing that we have to change is post.find by ID. And then we need rec.params.id. So when you're retrieving a post, what we're going to do is we're going to have the user go to localhost, colon 3000 or whatever, and then say, API v1. I'll skip that for now. And we'll say they want to go under the posts. And then here they would pass in whatever ID. So if they want the post with an ID of 5, they would pass that. And to retrieve that value, we just do rec.params.id. And, within our route, we're actually going to just do :id so that we can pass whatever value the request is into the params.id. So we retrieve that. We don't need the results because it's not going to be an array. And don't have to do this, but we're going to only return an individual post. So we'll just say post. And that should be all. So then the next thing we want to do is for creating a post. And actually, instead of writing this out, let's just copy this exactly. And we'll call this create post. And then we'll remove this. And we'll just say post.create. And we want to just pass in rec.body. So the title and the body that the front end sends, it's going to be attached to our body property. So that should be all that we need. We can return the same stuff. All of that looks good. All of that looks good. And then we just need two more. We need update and delete. And we're going to copy the get one for the update. So this will be update post. And the method we're going to use is find by ID and update. And so first of all, we have to pass in what the ID is. So just like we did for get one post, we can just pass in rec.params.id. And then we have to pass in the body. So rec.body, which is going to have the content of our post. And then a couple of other things that are optional. So I forget what these do. Just pass it in. I know run validators is going to ensure that even when you update, it's going to make sure that, like if we go back to the models, even when we update, it's going to check to make sure that we have a title as well as a body as well. So it's just going to do all of the Mongoose schema validation even on an update, which it doesn't do by default. And I believe this is to return the new post that gets created, but I could be wrong. And then lastly, we want to do our delete. So let's just copy this. And we'll change this to delete post. And all we have to do is let's delete all of this. And we're going to call find by ID and delete. And we just pass in rec.params.id. And in this case, there's no data, so we can just pass in null, or just not even include that, actually. All right, so we've got all of our CRUD methods done. Our controllers are set. The next thing that we have to do is just define our routes. So let's go into our routes, and let's create a file called postroutes.js. And in here, we want to import Express. And let's import our post controller as well. And let's create a new router. All right, and then let's start defining our routes. So we do router.route and then the specific URL. So this is just going to be the slash URL, the slash path. And then now we can chain in what we want for our get method and then what we want for our post method as well. So get and post, remember, they're always going to be, if we actually take a look at the URL, it's going to be, localhost 3000. And then if you go to slash get, then it's going to call this specific route. And if you go to slash post, it's going to create a new post. So that's how that's going to work. So let's add the controllers into here. So the get method is going to call the post controller get all posts. So post controller dot get all posts. And then for the post method, this is going to create a post. So we'll do post controller dot create post. Then let's go to our router instance again and do route. And then here, the route's going to be actually /:ID. And so anytime you pass the ID, you're usually going to do either an update or a delete, or a get one post or an individual post. So here we'll do get, and then we'll pass in our post controller dot get one post. And then we'll also do a dot update. No, sorry, not update, patch. And we'll call post controller dot update post. And then we also want a delete, which is going to be post controller dot delete. And then we'll do module dot exports equals router. And now let's go back to our index.js file and let's wire that router up. So here we'll call it post router, which equals require, and then our path to routes, and then post routes. And then right under here, we'll say app.use. And then we want to pass in the URL. So here we can say /posts and then post router. So what is this? What's actually happening here? So basically, if someone sends a request and it has and it looks like localhost :3000 /posts. So if that first keyword after 3000 is posts, it's going to send it to our post router. And then that's going to go to here. So this is where our post router is defined. And so it's going to strip off that posts now. And then we're just going to be left with either :3000/ or :3000/ID. So then it's going to match one of these. So that's all I'm trying to do. However, I usually like to do /API/v1. So here you pass in API so that you know that this request is for your API in case you're hosting your front end and your back end within the same domain. And then I like to specify the version of our API. So this way, at least it keeps your different versions independent. So you can start a second version and they can run side by side. And so now basically, if there's a request to API v1 /posts, it's going to go to our post router. And let's save everything. So it looks like nothing's broken, but let's test this out. I'm going to bring up Postman and let's just say API /v1 /posts. And let's do a send. And look at that. So it looks like things are working. So we can see it's a success. We got no results because we haven't created anything. So that works. Let's now try to create an entry. So we'll do post and then go into our body. And then let's do raw and then JSON. And then here, let's change this. So we need a title. I'll call this my first post. And then we need a body. And we'll say, I don't know, body of first post, whatever. Let's send. And it looks like we got an error. So let's see what happened. Now we went to post routes and under, actually, let's go to our controller where we create a post. And then here, let's just do a console.log e so that we can see exactly what's happening. And it says, oh, post must have a body. It does have a body. And I realized I know exactly what happened. So to actually attach the body of a request onto our request, actually, I worded that weird. But for Express to actually take the body of the actual request and attach it to that request object that our controllers have access to, we actually have to pass in a middleware. So let's define that middleware real quick. Under our index.js. Right here, we'll just say app.useExpress.json. So that's going to ensure that the body gets attached to the request object. And now if I hit send, we can see that it successfully created the post. We got the ID back from Mongoose, so that worked. If I go back to the get and then get all of our posts, we should see that show up. Perfect. Let's update now. Let's update that post. So I'm going to do / and then we got to copy the ID of this post. And I'm going to change this to my first post updated. Let's hit send. And we can see that the title got changed to updated. And if I do a get and remove that ID, my first post updated. So we've successfully updated a post. Let's try to get an individual post. So let's send that. We got the individual post. And then let's delete that post as well. Let's delete it. Success. We do a get now. Nothing. Perfect. Let's just add a few entries just so that we can have something in our database. So I'm going to go to post. Let's just create a couple. So got one and change this to second post, third post. And then let's go back to our get method right here and let's send. And we should get 3 entries. Perfect. So now we've got a basic CRUD application. And I think that's a good stopping point for this section. Okay, so we got our basic CRUD functionality going with our blog posts. However, I want to start to implement a user sign up and login functionality. And the reason I want to do this is because I want to introduce one more container. I want to introduce a Redis container. So we're going to use Redis for authentication, but to do that, we have to implement the whole user sign up and login flow so that we can actually get that wired up to our Docker application. So let's quickly get started on that. I'm going to try to blitz through it as quickly as possible once again so that I can show you how we can wire up a Redis container. And so, just like we did with our posts, we're going to create a user model. We'll import Mongoose. And then let's define our schema. So we'll do const user schema. And there's going to be just 2 properties, the username and password. So we'll set username is going to be a type of string. And this is going to be required. So we'll set required to be true. And then if they don't provide it, we'll give it an error of user must have a username. Then we have to pass in another property, which is unique. So we can't have 2 users with the same exact username. So this is going to do a little bit of validation, ensure that if we're creating a new user, that username is not already taken. And I'm going to copy this. And for the second property, it's going to be the password. So I'm just going to change this to be password. Type string, we don't need it to be unique. Required, and we'll just say user must have a password. So here we'll say const user equals mongoose.model user and then user schema. And then we'll just say module.exports equals user. We've got a model. Let's actually set up the controllers now. So we'll call this auth controller. And let's import our user model. And let's set up our controller for signing up. And then within our try catch block, let's do user.create. And we can just call in rec.body, which should have the username and body. And then we'll await this. And we'll set that to new user. And then here we'll just do res status 201.json. And we'll say status as success. And we'll return the new user. And if this fails, we'll just do a res.status 400. And we'll say status fail. So let's try this out. Well, actually, first of all, we have to wire this route up. So let's go to our routes. Let's create a new route. We'll call this user routes. And we'll say const express equals require express so that we can get that router object. We'll do router equals express.router. And we'll say router.post. And this will be for sign up. We get our auth controller. So we have to import our auth controller. And we'll call up the sign up method. And then we'll export that. And then we need to wire it up into our index.js. So here we'll do const user router. And just like we did before, we're going to do app.use. Here, let's specify the URL this should get routed to. So we'll go to /API/v1/ we'll just say users. And then we'll pass in that user router. And let's save all files. And let me just make sure that there aren't any errors. So it looks like everything's good. And let's try this out now. I'm going to create a new request. It's going to be a post. This is one that's going to go to users /signup. And then we need to pass in our body. It's going to be JSON. Say user name is set to Sanjeev. Password is set to password. Let's try this out. And it looks like it worked. It's perfect. A couple of issues though, obviously. First of all, I don't want to return back the entire user. But really the bigger issue is that, first of all, we're just storing this in plain text, our password into plain text. So let's fix that. And so to do that, we need to install a new library, and that's going to be the bcrypt library so that we can hash our password. So I'm going to stop this for now, and I'm going to do an npm install bcrypt.js. And we got to do a Docker compose down and then back up. And we got to do a rebuild as well of the image. We'll do up-d-build. All right, so everything's back up and running. So let's hash our password. So if we go back up to the auth controller under sign up, what I'm going to do is, first of all, I'm going to grab the username and property from the body with a little bit of destructuring. And let's import bcrypt. And then here we'll do const hash password equals, and then we'll just do an await and then do bcrypt.hash. And then here we're going to hash the password, and then we have to pass in a value. So this is going to be the strength of the hash. We're just going to pass in a value of 12. I think that's a standard number that people use. And then when we do new user, we have to change this now. So we'll pass an object, and the username will be set to username. And then the password is going to be set to hash password. Let's try that out now. So now if we sign up, I'm just going to put a 1 here. We can see now that it has a hash password. So perfect. Now let's implement the login functionality. So we're going to define a controller for login. And once again, we're going to destructure out the username and password. And I realized, first of all, back in our sign up, let's make sure we get this in our try catch block because this could fail as well. And here we're going to find our try catch block as well. Actually, I'm going to copy and paste it. Let's save us some time. So first things first is let's delete this. And what we want to do is we want to find, we want to check our database to see if we have a user with that username. So let's do const user equals await user.find1 with a property of username. And then we'll do an if statement to see if user was found. Actually, we'll say if user was not found, then we'll just send a res.status 400. Well, technically it would be a 404. It doesn't really matter. JSON, and then we'll just say status, fail. And we'll just say message, user not found. However, if we did find a user, actually we want to do a return. But if we did find a user, then we want to say, we want to first of all check to see if the password's correct. So when you hash a password, what we have to do is we have the hash password stored in the database, and then we have the password that the user is trying to log in with. So what we have to do is we have to hash the password the user tried to log in with and compare that hash with the hash that's stored in our database. And if they equal the same, then that means the user should be able to log in. So we'll say bcrypt.compare. Then we pass in the password that the user tried to log in with. And then we pass in from our user object, which it represents the entry in our database, we'll say user, and then grab the hash password within the database. And we'll take this, we'll do an await, and then we want to store the result with into a variable called maybe is correct. So that means his password is good. And then we'll say if is correct, we'll do a res.status 200.json, and we'll say status success. However, if it's not correct, then we'll just send a response status 400 again .json, and we'll say status fail with the message incorrect username or password. And we'll remove this. We don't need this anymore. All right, and let's save that. And now let's go back to here. So we did a sign up. Let's do a login. And actually, we have to define our routes. So you can see here, we just have a route for sign up. Let's copy this and let's create one for login as well. It's going to be pretty much the same thing. So login. It's also going to be a post method. And then in this case, this is going to be a login. So we created a user with this username and this password. So we should be able to just change the URL to login, and this should work. So let's try this out. And we get a status of success. If I put in a different password, incorrect username or password, change it to the correct password, and then change the username to something that doesn't exist, and we can see user not found. Perfect. All right, so we've got our user. We've got the user sign up and login working, relatively speaking. But the next thing that we want to do is we want to actually handle the authentication side of things. So when the user logs in, how do we actually store that state within our application? And we're going to use sessions to do that. So we'll tackle that in the next video. All right, so now let's actually go ahead and implement authentication in our application. Because right now a user can sign up and it can log in, but how do we actually make it so that to retrieve posts, maybe modify posts, a user has to log in and authenticate first? Well, we're going to use something called express sessions. So there's really two different ways of handling authentication. We can use sessions, or we can use JSON web tokens. I decided to use sessions because really I went through all of this process just to show you that we can add in a Redis database. So we can use a Redis database to store our sessions. And you'll see that wiring up an express session to work with Redis is dead simple. And if you actually scroll to the bottom, it actually shows you all the other compatible session stores. So if you want to store it within the Mongo database that we're already using, you can do that. If you want to store it within a Postgres database, if you want to store it in memory, you can. But what we're going to do is we're going to do it with Redis so that I can show you how to deploy one more container. So let's just search for Redis. And here you can see connect Redis. And this will walk you through the whole process of getting express sessions wired up with a Redis database. Now, what we're going to do is before we do that, let's go ahead and actually get ourselves a Redis database. So let's go to our images in our Dockerhub, and I'm going to search for Redis. And there's the official image is going to be the first result. So let's add this. So the name of the image is going to be Redis. So let's go to our Docker compose.yaml. And let's wire this up. So under Mongo, under that service, let's create a new one and give it any name you want, but I think Redis makes sense. And then here, we want to pass in the image, and that's going to be Redis. And once again, I did this in the shared file because both in our production and our development environment, we're going to need a Redis database. Now at this point, right now, if you take a look at my setup and I do Docker PS, you can see everything's running. So normally you think that you would have to do a down and then an up right afterwards, but there's a shortcut. What we can do is, since we made a change to Docker compose.yaml, we can do an up again, even though everything's already up and running. And Docker Compose is smart enough to know to detect any of the changes that we've made and spin up the necessary spin up the necessary services that we've defined. So if we do up and then once again do -d, what's going to happen is it's going to see that we added that Redis database, and it's going to spin up a Redis database. Right, and so you can see both of these are already up to date, so it was able to tell that nothing's changed there. But we did add the Redis, so it's going to go ahead and pull that up. So you'll see moving forward, I'm just going to run the up command just to make any changes take effect instead of having to do a down and then an up, because that's just too long of a process. All right, so we've got our Redis database. Now let's go back to here and let's see how we can wire up this connect Redis and express session. So we have to do an npm install, and then we have to install these 3 libraries. So we have to install Redis because we are interacting with the Redis database. We do have to install express sessions because we're using the sessions functionality. And then to wire those 2 up together, we need the connect Redis library. All right, so let's do a npm install. I already forgot what libraries I need. Just going to copy this. We'll install those. And then now, like I said, we can do a down, Docker compose down, and then do a Docker compose up with a -- build because we did install new dependencies, so we have to rebuild our node image. However, what we can do is just do an up -d -- build. And that's going to, rerun everything for us, so we don't have to bring it all down. However, there's one more issue. So if I do a -- help, you're going to see that there's this renew anonymous volumes. So when you have a database, sorry, not a database, when you have your containers already up and running, and then you do another up and you want to rebuild the image, what's going to happen is that the already running container for our node application is going to grab the old anonymous volume. And the old anonymous volume has all of our old dependencies and packages that we've installed. But we've installed some new dependencies like Redis. And so we need to force Docker to renew a new anonymous volume. So instead of using the old one, we needed to create a new one and not use the old node modules folder that doesn't have Redis or express sessions. So you can just do a down and then an up with the -- build like you normally can, or you can do just an up again with the -- build and then make sure you pass in the $V to ensure that we create a brand new anonymous volume. All right, so we've got all of that. Let's take a look at the example. You'll see it's pretty easy. We have to import Redis, express sessions. We have to create a Redis store. And so it's literally just copy and paste up to here. And then here under Redis, under our create client method, we have to specify how to access our Redis database. And then we just pass in this specific middleware that we create. So let's get to it. So let's go back here and let's go to our index.js. And we're going to import sessions first. So we'll do const session equals require express that session. Then we need to import Redis. And then we have to define our Redis store. So we'll do let in this case. So we'll do let Redis store equals require. And then we need connect -Redis. And then we pass in session. And then let's define our Redis client. So we'll do let Redis client equals require. Sorry, not require. We want Redis dot create client. And then here we have to pass in 2 things. We have to pass in the URL, the host URL, as well as the port that the Redis server is going to be listening on. All right, so let's go to our config.js and let's define that here as an environment variable. So we'll say Redis underscore URL. When I say URL, this is just going to be the IP address. So I'll just say process.env.redis underscore URL. And then if that's not set to anything, we're going to default to Redis, right? Remember, we have the DNS at our disposal. So, anytime any one of our containers wants to talk to our Redis database, and it needs to know the IP address, we can just reference Redis. So if I go back to config.js, I'm just going to default to Redis. I'm, in production and in development, I'm never actually going to pass this URL in. It's just there so that in the future, if I do decide to have a Redis database that's not a Docker container and that I can't actually resolve using Redis, then I can just pass it as an environment variable, and then I can connect to maybe a managed Redis server. So back here, we'll pass in host as Redis_URL. And then we also have to pass in the port. So we're going to use the default port for everything, but let's define a environment variable for that. So we'll call this Redis_port. And this is going to be set to process.env.redis_port. And we're going to define, we're going to default to whatever the default port is for Redis, which is 6379. All right. And then right down here before our first middleware here, I'm going to define a brand new middleware for our sessions. So here we'll then pass in session. And then we have to pass in an object. So the first thing that we have to do is we have to pass in our store. So here we'll call it new Redis store. And then we have to pass in our client that we created. So it's going to be client. And then we're going to reference our Redis client right here. All right. Then the next thing that we have to pass in is a secret. So this is just a random secret that we store on our Express server that we use when we are handling the sessions. So this can be any string. So what I'm going to do is I'm going to create an environment variable for that as well. So we'll go back to our config. And I'm going to create one, and I'm going to call this session_secret. And we're going to grab this from process.env.session secret. And so this is going to be session secret. Make sure you import that. And then we have to pass in some properties for our cookie that we send back to the user. And so if you want to take a look at the properties that we're going to pass in, go to the original express-session page. And then here under the options for cookie, you'll see the different options that we have. So we've got expires. So actually, we don't even want that. We want max age. So I think it's somewhere here. Anyways, I'm just going to pass in a couple of the ones that I'm going to use. And then, if you guys want to read up on that, feel free to. But it's not really that important from a Docker perspective. So we're going to do secure. I'm going to just set that to false just to simplify our application. Resave, set to false. Save initialized. HTTP only is going to be set to true. And then max age, this is going to be set to, so this is set in milliseconds. So I just want this cookie to last 30 seconds. It's going to be a little bit, I want it to be that short just because it's easier to demonstrate how these cookies work. I'm going to do 30,000 milliseconds, which equates to 30 seconds. And I know HTTP only, this is just used for scenarios where your JavaScript on the browser will not be able to access it. So HTTP only means that JavaScript can't access it. All right, so we've defined a couple of new environment variables. So let's go back to our Docker compose file. And well, first of all, let's go to dev anyways. So this is going to be the environment variables for our development environment. So let's go down to Redis. And let's set our environment variables. And once again, I made a mistake. These aren't set for the Redis server. This is going to be set for our Node app. And the only thing we need to pass in is our session secret. So we'll do session_secret. And then just pass in some string. So I'm just going to call this secret. Why not? It's just an arbitrary string. Just think of it as like a password for your sessions. And so now let's do a Docker compose up. However, if we just do a Docker compose up, you'll see that nothing happens because, well, actually something did happen. This is actually perfect. So it recreated the container just because we changed a few things. We changed our environment variable. So it was able to start that. And let's do a Docker PS. We'll do a Docker logs. And then where's our node app right here? And then we'll just do -f. And it looks like I forgot to import Redis URL. So if I go under index.js, this was never imported. Well, it actually is imported. I just imported it down here. So we just have to cut that out and then move it below this line. And then on port 18, I never actually imported. So this is going to be set to port, and let's import. Actually, is that defined here? We need to make sure. Yep, we didn't. We never. Oh, it's Redis _port. Okay. Import that. So make sure you import it there. And I think this should fix our issues. It looks like things are good so far. So let's. Well, actually, technically nothing's done yet, but all right. So we've got our sessions wired up. The next thing that we have to do is we have to create a session whenever a user logs in. All right. So now that we've got our sessions wired up, let's try to log in again and see if anything's changed. So I'm going to do a post request to our login route, and I'm going to pass in the credentials to a user that's already been created, and then we'll hit send. We get a status success. And you'll notice that under this cookies tab, there's a 1. So this implies that we received a cookie with the value of 1. And so this is what our cookie looks like. You'll see the domain is set to localhost because that's what our server's running on. And then you'll see our expires section, which is going to expire in 30 seconds. And then some of the other properties like HTTP only set to true. And then secure. Secure is basically if you've set secure to true, that means it'll only work with HTTPS. I'm not going to go over how to set up SSL and HTTPS and all of that for this video, but in a production environment, you definitely want this set to true, and then usually in development, you just leave it set to false. So let's log in. What I want to do is I want to actually log in to our Redis database and just show you what that looks like, what that session looks like within the database. So I'm going to, we'll Control-C out of this. And then let's just do a Docker exec. Well, first of all, let's do a Docker PS. Let's get the name of that container. So Redis. And we'll do a Docker exec -it. And we'll drop into bash. And from here, we can just type in Redis or Redis-CLI. And so that's going to drop us into our Redis database. However, once again, just like we did with Mongo, we can kind of shorten that and just do Redis-CLI. And so now we're in Redis. And to see all of the entries within our Redis database, all we have to do is just type in keys and then star. All right? And you'll see that it returned an empty array. And you might be wondering, why did it return an empty array? We have a session. Well, if you recall, where I set some properties on my cookies and my sessions is that this is only going to last 30 seconds. So the session dies after 30 seconds. So what I'm going to do is I'm going to re-log in. This should create a new session. And then now let's quickly run the same command. And you can see we have a session right there. And if you want to see the details for a session, you can type in get and then the key for that. So here we can just copy that. And I forgot the other quotes. And there you go. So this is the details of that session. It's got some information about the cookie and a few other things. But with this session, we can add any information that we want into this session. So what we ideally want to do is when the user logs in, we want to store the user information within this session. And so if that user information is in that session, then we know he's logged in. If it's not, that means he's not logged in. And the nice part about doing this is that we can store any information we want in the session, even information that's should be private to the user, because the user never gets to see the session. This session resides in our Redis database. It never gets sent out to the web browser the user's trying to connect from. So to do this, let's go to our auth controller. And it's very simple. So let's go under our login section. And right before we actually implement the logic for logging in, so right under is correct, what we can do is we can say rec.session. So this is how you access this session object. It's going to be attached to the request object. And we can add in a new property called user. We can create any property we want. And we'll just set that to, let's see, where is he? User. We'll set it to user. And so that's going to take the user object that we found from our database. And only if our password, our login is correct, will we then log, or we will assign this user object to our session. So let's save this. Should restart our app, and let's log in again. And now I'm going to do keys star. We have our session object, and then I'm going to do a get. And now take a look at this. So here, starting at this section right here, this is our user object. We've got the MongoDB ID that assigned it. We've got the username and the password. So this is how we tell that a user is logged in. And then after 30 seconds, you'll see that it goes away. And so if we do a keys star, it's gone now. So now that you have an idea of how the sessions work, let's go back into our index.js and just change this value, because obviously 30 seconds is way too short. We can change just add whatever you want. I just added a couple of zeros. However long you want a user to be logged in, this is the value you set in there. Remember, we use milliseconds, of course. And before we move on, a couple other things. So after a user signs up, we also want to do the same thing. So after he signs up, we want to make sure that we log him in by doing rec.sessions.user and set that equal to new user. And let's test that up. So I'm going to go to sign in or sign up. And we'll just do Sanjeev 5. All right, that worked. We got our cookie. Let's do that. And let's get the details for that session. And we can see it did not work because I do not see any information about my user. So let's take a look and see what we might have broke. And I already see what I broke, so it shouldn't be sessions, it should be session. And so let's sign up with a 6 this time. So we have a new user. And so there we go. So now we can see username Sanjeev6. So now whether we log in or sign up, it's going to assign the user to our session. And so now we can access that user whenever we want to access posts. So now that we have our sessions tracking whether a user is logged in, let's set up the logic to make sure that for a user to either create or delete or update a post, or even get posts depending on how your application works, they have to be logged in. And the way we can accomplish that is by using Express middleware. And a middleware is nothing more than a function that runs before your controller. So this function is going to have a little bit of logic, and all it's going to do is it's going to check that sessions object to see if there's a user property attached to it. And if there is a user property attached to it, then it will then forward the request onto the controller so the controller can handle that logic. However, if there is no user object attached to it, then it's going to return an error saying, you're unauthorized to access that, you must log in. So let's create a new folder for our middleware. And I'm going to just create a file called auth middleware. And here we're going to create our middleware. And I'm going to call this protect because it's going to protect a route and ensure that a user is logged in to actually access that endpoint. And with the middleware, you get the same thing as any other controller. You get request, response, and then you also get the next object. And so here what we're going to do is we're going to destructure out user from our session. And we're going to say if user does not exist, which means, the user's not logged in, because if there's no user attached to the session object, then we know the user's not logged in. We're just going to return a response that says, First of all, we're going to set the status to 4.1, and then we'll do JSON. And then here we'll say status fail. And then what we're going to do is we're going to send a message that's going to say unauthorized. However, if the user is logged in, then we're just going to say next. So when you call the next function, then or the next method, it's going to then just send it to the controller or the next middleware in the stack. And one optional thing that you can do, and what I like to do is, instead of having all of the rest of our routes get the user off of rec.session.user, I'd rather have it attached directly to the rec object. So I'm going to say rec.user equals user. So now if we ever want to get the information regarding the user, we can just do rec.user instead of having to go to rec.sessions.user. Then we want to make sure we export this. All right, and so now under our post routes, which is the routes that we want to protect, let's import our protect middleware. And to protect a specific route or endpoint, let's grab the post method right here. So this is going to be when a user wants to create a new post. And all we have to do is just pass in protect here. So what's going to happen is when a user hits this endpoint, we're going to run our middleware function. And our middleware function is going to verify if the user is logged in. If he is logged in, then we just call the next method, which then goes straight to postcontroller.createPost, and then all the logic for that gets run. However, if he's not logged in, well, our middleware is set to respond and send a response back. And we call a return, which means we don't go through the rest of the middleware or the controller at the end. We just kill the signal and we send a response back. So that's how authentication works. And so the last thing I want to do is for index.js. First of all, I'm going to change this back to 30 seconds. You can pick 60 seconds too. Actually, let's just do 60 seconds. And let's save everything. All right. And what I want to do is, first of all, I'm going to log in. Let's delete all of our previous cookies just to make sure we don't have some kind of weird stale state. And then let's log in. So we'll log in. And you'll see that this is set to expire in 1 minute. That's in GMT, I'm in EST. So it's going to expire in 1 minute, but we're logged in. So let's actually create a new post and let's hit send. And it looks like we are successfully able to create a post. However, if we wait 1 minute for our session to end, let's then try to see if we can create a post. And ideally, we should not be able to. So I'll see you guys back in 1 minute. All right, so it's been about a minute. Now let's test to see if we can still create a post. So if I hit send again, we should see that it failed and it says we're unauthorized. And that's because our session ended. And basically once your session ends, you're essentially logged out. So if we log back in, it's going to create a new session. We're going to be logged in for 1 minute. We can then create another post. All right, so we've got our authentication set up. We can just decide on what routes we want to protect. So you can use this same middleware across your entire application. So for deleting or updating, we can add in protect as well. Actually, let's just add it in for everything. So even retrieving post, you have to be logged in. And, for a real world application, you ideally want to bump this up to something significantly higher, maybe a couple of hours or something like that, or even a couple of days. I'm going to keep this actually at 30 seconds, just, for testing purposes. So as we keep going with our application, I want to make sure that authentication doesn't break for whatever reason. And so from a Express point of view, we're kind of done building our application. I know it's not like a full-fledged application. It was never meant to be. I just wanted to have enough of an application so that I can show you from a Docker perspective how everything works. So this is all we're going to do. I know we don't have like a logic to assign, posts to a specific user. Right now, any user can create a post, edit any post. And so it's just one big global list of posts. But, remember the idea of this tutorial series is not about the Express application, it's about Docker. So we finished the Express application side of things. We're going to get back to the Docker side of things in the next video. So we still got a ton of things to learn. And we're also going to eventually move on to getting all of this deployed to a production setup and then show you guys some of the challenges we face when moving to a production environment. All right, guys. So before we proceed any further, I want to do a quick review of the architecture of our current application. And then I want to show you guys what I ultimately want it to look like once it's done. So here I've got a little diagram. We've got in the blue, so this big blue box, this represents our host machine. So in this case, this is my Windows machine. And so here we've got our Express application that's listening on port 3000. And then we've got our Mongo database, which our Express application can talk to on port 27017. And if we need to actually send a request to our Express application, then we just send a request to port 3000 to our local machine. It'll then get mapped to port 3000 of our Express application. And so that's the current architecture. And, one of the things I wanted to point out, especially when we started to add the Mongo database into our application, is that we never opened up a port for our Mongo database, right? So just like we opened up port 3000 for our Express server so that the outside world can talk to it, we never did that for our Mongo database. And I actually did that on purpose because, we definitely could open up a port so that we can talk directly to the Mongo database. So we could open up, port 27017 on our local machine, or really any port really, and then map it to port 27017 to our Mongo container. And that would be perfectly fine if you needed to talk to our Mongo database. However, I want you to think about what that would ultimately mean. Because now we're letting the outside world talk to our Mongo database, right? The only thing that actually needs to talk to our Mongo database is our Express application. So there isn't really a need to open up that port. And it's also a little bit of a security vulnerability because your database holds all of your critical application data. It's got all of your user information. It's got all of their emails. It could have potentially other sensitive information like social security number, passwords, and other things like that. So generally, it's best not to make the Mongo container accessible to the outside world. And I love how Docker by default, if we don't open up any ports, it already isolates the Mongo container. So the outside world can't talk to it. So you can see that just by running with Docker, we've already added a little bit of security to our application because only our Express application and our containers within that container, within that network that Docker Compose makes can talk to that Mongo database. No one else can. So once again, just to reiterate, we aren't going to open up any ports to our Mongo database. Just like in our Docker Compose file right here, you can see we open up the ports for our Node app, but there's no ports opened up for Mongo. So we're not going to open up any ports. We're going to make it so that only our application, our Express app, our Express container can talk to our Mongo database. And so, like I said, we're not going to publish a specific port for our Mongo database just for security purposes, and there's really no reason to. So we're going to actually remove that. And so now what I want to talk about is scaling up our Node containers. So, we talked about passing in that scale flag so that we can increase the number of Node containers that we have so that we can handle an increased load in traffic. So what we did was we would spin up another Node Express container, which would then connect to our Mongo database using the same exact port. And to be able to talk to this container, what we would have to do is publish a different port. So the first Node container, you could see that if we send a request to port 3000, it would get to map to port 3000 of the first container. And then we'd have to grab a different port on our local machine, like 3001. And so any traffic that gets sent to our local host on port 3001 would get mapped to port 3000 on our second Node container. And if we wanted a third one, we'd have to open up another port like 3002 and so on. So if we had 50 containers, 50 Node apps, we would need to open up 50 different ports. And, like I said, that's not a scalable solution. Our front end shouldn't have to be aware of the number of Node containers that we're running on our back end. So what we're going to ultimately do is we're going to add a load balancer. So there's a couple of different options that we have. You have things like HA proxy, you've got traffic, and then you got Nginx. So I'm going to walk you through how we can do this with Nginx. And you'll see it's really simple. And it's a good skill set to have because you'll use Nginx in other scenarios outside of Docker as well. It's a great web server as well. So ultimately, what our final architecture is going to look like is we're going to have a Nginx container. And this Nginx container is going to be the entrance into our application. So we're no longer going to publish any ports on our two node instances. So we're no longer going to open up port 3000, port 3001 on our local machine. Instead, we're going to publish one port for our Nginx container. And that port can be anything. So we can continue to use 3000 like we have, or we can pick any other port. And you'll see that, when we get to production, we're just going to use port 80 because that's the default port for HTTP, as well as port 443, which is the port for HTTPS. So we'll open up, the port of our choice on our local machine, and we're going to map it to port 80. The reason we map it to port 80 is because that's the default port that Nginx listens on. Technically, that's fully customizable, so we can tell Nginx to listen on a different port, but there's no need for the extra configuration. I'd rather just leave it to the default port. So, port 3000 is going to get mapped to port 80. And then what our Nginx is going to do is it's going to act as a load balancer. So every request that it receives, it's going to load balance it to our 2 Express instances. And if we have 4, 5, 1, or 1,000 instances, Nginx will be able to load balance all of those requests across all of our node instances. And so this is a much cleaner, elegant solution because, first of all, we only have to publish 1 port, and then Nginx, which is highly efficient, is going to be able to ensure that all of our node instances are adequately balanced with regards to the number of requests that they receive. All right, and so that's all I wanted to cover in this section. So in the next video, we'll get started on adding that Nginx container. If you search for Nginx on Dockerhub, you'll see the official Nginx image as the first result. So this is the one that we're going to use. And so let's get started on configuring this. First thing that we need to do is I'm going to create a separate folder for our Nginx configuration. So I'm going to call this Nginx. And we're going to create one file, and that's going to be the default.conf file. So this is just going to be a basic configuration for our Nginx server. And within here, we have to define a server block. And so this is all just Nginx specific configs, nothing related to Docker. And here we'll just say our Nginx server is going to listen on port 80. And then now this is where we actually set it up to redirect traffic to our Express or our node containers. So we say location, and then we provide a URL. So this is going to be the URL of the request this Nginx server receives. And so here we could just do a / and then put in all of our configs. And then here we can say the most important one is proxy _ pass. And then here for the proxy pass field, we specify the URL of the servers that we want to proxy this traffic to. So we want to send this traffic to our Express application or our node containers. So because our Nginx server is also a Docker container that's going to be running, it has access to DNS. So what we can do is we can type in HTTP : / and then we can say node-app. Because remember, we have that custom network that was created by Docker Compose. And so within our Docker Compose file, we can refer to any one of these services by their name. So if I call node app, it's going to load balance between all of the node app containers that we have. And then we have to make sure that we send it on port 3000 because that's what our Express servers are listening on. Now there's a couple of other properties that we need to set. Now, because Nginx is acting as a proxy, when we actually proxy the original request to our Express application, the Nginx server is going to strip off a few details. And these details may actually be important depending on what your application is doing. And one of the things that Nginx does is you'll lose the original IP address of the sender. So, what was the IP address that originated that request? So we can tell Nginx to make sure that we forward that along to our node applications. Now, our node application isn't actually making use of that, but if you're doing any kind of like rate limiting per IP address, these are all things that you want to need. So it's always best practice to configure this. And so to ensure that we pass on the original sender's IP, we do proxy _set _header, and we do x -real -IP, and then we do $remote _ADDR. All right, and then another thing that we want to do is we're going to pass in another setting or flag that's going to provide us a list containing the IP addresses of every server the client has been proxied through. So this is another thing that's just best practice. I definitely recommend you read up on Nginx. There's a lot of things that you can do and configure, but I'm just trying to get you guys up and running with the base configuration. And so I'm just going to copy this. It's a little bit of a long line. All right, and so that's going to make sure all of those proxy server IPs are attached to the headers. And then we're going to add in just a few other fields. So we'll do proxy underscore set underscore header, host, and $HTTP underscore host. And then we're going to copy this again. And so that's all the configurations we need. However, there's one minor tweak that I want to do. In this case, basically all requests are going to get forwarded to our Node app. Now, for what we're doing, we're just building a backend. However, if you wanted this Nginx server to also handle serving your front end assets, what you would ultimately want to do is in your API, and we've already kind of set this up, is that for all of your routes, you want to make sure that they are listening on API /v1 / something. So that way we know that the Nginx server can actually specify that any request that starts with API is meant for our backend, and then any request that's meant for a URL that does not have the API, that's meant for our front end. So since all of these requests are listening for API first, well, except for this one, but we can add that real quick. What we can do is we can go back to that configuration file and we can say /API. So in this case, whatever URLs passed for location, this is going to specify what the request needs to look like for us to forward it to our Node application. So any request that comes in starting with /API, we'll send it to our Node app, and then anything that doesn't have /API right now is just going to drop. But in the future, we could configure it so that it can handle, redirect that traffic to our Nginx. Sorry, not our Nginx, but like a React application or whatever our front end application is. Right now, let's go ahead and go to our Docker Compose file and let's add our Nginx service. We can do Nginx, and then the image. This is going to be Nginx, and then we can. And let me put a space Nginx, and then I'm going to grab the stable Alpine version. All right, and so now, first of all, we no longer have to publish ports for our Node application, so we can remove that actually. And let's actually go into our dev and prod, make sure we remove any of the ports being opened there as well, and it doesn't look like we have anything. And prod looks okay, and so let's go back to our Docker Compose. And then here, let's open up a port. So we'll say ports. And then let's pick the port that we want to publish. So pick anything. We can do 3000 still if we want. And then we just want to make sure we map it to port 80 because that's the port that our Nginx server is listening on. And for production, actually, let's I'm going to copy this. For production, it's going to be a different port. So instead of opening up port 3000, we're going to open up port 80. And we can remove that image because we're not changing anything. And actually, why even have this here? I can just copy this and put this in the dev section. All right, now the next thing that we have to do is we have to get our configuration file that we built out into our Nginx container. So there's a couple of different ways we can do this. We can create our own custom Nginx image that already has our configuration built in, or we can just configure a volume, specifically a bind mount, and just have it sync those two files. And so I think that's the route we're going to go. We're just going to configure a bind mount so that we don't have to worry about building a custom image and doing all of that nonsense. So under volumes, so you have to understand a little bit about where Nginx looks for this config. So Nginx is going to look for this in the /etc/nginx/conf.d/default.conf file. So that's where it expects the configuration. And we're going to sync that with nginx default.conf. So we'll just go /nginx / default.conf. And then on the Nginx container side, we're going to make this read only. It should never have to change the configuration. So a little bit of a security check. And let's tear everything down. And let's build it back up. We're just going to do one instance just for now. Let's just make sure everything's working. And let's try sending a request. So we're going to try to log in again. And let's go to the body here. And it looks like we broke our application. So let's take a look and see what exactly we broke. All right, guys, so I made a stupid mistake. I just forgot to update this to port 3000. So I had left it at 3001. So make sure we change that to 3000 because that's what our Nginx server is listening on. So now if I log in, we can see that it's successful and we did receive the cookie. All right, so it looks like we got our application up into a working state using Nginx as a proxy so that I can load balance requests to all of our node instances. But there's a couple more things that we got to do. So what I'm going to do is I'm going to pull up this web page right here. So I just want you to search for Express and then proxy, and it'll be the first result you should get. And it just explains that we do have to add one extra configuration into our Express application whenever our Express application is sitting behind a proxy. And this isn't technically required for our example, for our demonstration project, but in a production grade project, you probably will need to add this. The configuration right here is this app.set trust proxy. And so all this is saying is that we're going to trust some of the headers that our Nginx proxy is going to be adding onto the request. And so remember, we configure our Nginx server to basically add the originating sender's IP address into the headers so that if our Express application does need it, it has access to it. All we're doing here is we're just telling Express to trust whatever our Nginx server is adding onto those headers. And so all we have to do is we have one simple configuration. So if we go to our middleware, we have our session middleware. So right above this, we're going to do app.enable, and then we just say trust proxy. So that's the only thing that we have to do. But this is really just in cases for when you need access to that IP address, which we don't. But if you're doing some sort of rate limiting, it's going to be necessary. So now that we get that done, the last thing that I want to do is I want to scale up our application again. So I want to add a second node instance. So what we're going to do is, first of all, I'm just going to tear everything down. All right, and then we're going to bring everything back up. But this time we're going to pass in the -- scale flag. And we're going to say node-app equals 2. So we have 2 instances. All right, and the next thing I want to do is, in one of our routes or one of our route controllers, I just want to do a console.log and just have it say something. It doesn't matter. Just say, yeah, it ran. The reason I want to do this is I want to verify that Nginx is actually load balancing the requests to all of our nodes, all of our node instances. So here I'm going to create a new window, a new terminal actually, and then I'm going to split screen this. So the window on the left is going to represent the logs for node instance 1. The window on the right is going to represent the logs for node instance 2. So here I'm going to do a Docker PS just so I can grab the name. And so I'm going to say Docker logs. I'll say node Docker node app. This will be node app 1 -f for follow. And I'm going to copy this. And then paste that here and just change this to node app 2. And so each time we send a request, I want to see a log get generated here first because of this console.log. And then ideally, Nginx should then send the next request to this one, and we should see that log get generated here. So I'm going to change this to API/v1. It's going to be a GET request. And let's hit send. And I think I forgot to save it. So let's save this. There we go. And now let's send the request. All right, so we can see it said, yeah, it ran on the left side, so node app 1. Then let's run it again. And so then we can see it runs on node app 2. So it looks like it's successfully load balancing. Let's just run it a couple more times to verify. So ran on the left side, ran on the right side, left, right, left, right, left, right. All right, so we've got Nginx up and running. I think that's a good stopping point for this section. All right, guys, so there's one last thing that I want to do before we actually start moving to our production server. And so I want to enable CORS. And if you don't know what CORS is, it basically just allows your front end to run on one domain and your backend API to run on a different domain. Because by default, let's say your front end is hosted at www.google.com, right? And let's say your front end sends a request to, I don't know, say www.yahoo.com. So let's say yahoo.com is where our API exists. Well, these are two different domains. By default, our API will reject that request from our front end. So to allow these to be running on different domains, we have to configure CORS so that different domains can access our API. If you're running everything on one domain, then you don't need it. But I'm going to show you guys how to configure that real quick. It's really simple. And so we're going to use this library called CORS. And you'll see that configuring is very easy. First of all, we import CORS, and then we just configure it as a middleware. That's it. 2 lines of code, and you're good to go. So here I'm going to do an npm install CORS. And so since we did add a new package to our package.json file, a new dependency, we're going to have to rebuild all of our image. So here we can do up -d --build. So that's going to rebuild the image. But remember, by default, when you run an up, a Docker Compose up, when you're already up and running, if you have a anonymous volume like we do in Docker Compose.yaml, and we're using that for, actually, where is it? It's under dev. So we have this for our node modules. What's going to happen is if we run an up when it's already up and running, it's going to use our old anonymous volume. That's going to have only the node modules before we ran the up command. And so to get the new CORS package added in, we need to make sure that we pass in the --. Actually, I have to figure out what it was. I have to run help to figure it out. We have to pass in the -v. So that's going to recreate a new anonymous volume. So we'll do that. -v. All right. And so now if we go to our index.js, let's import the CORS library. And then right here under app.enable, we'll just do app.use. And then we just pass in CORS. And then here you have a config option, a config object that you can pass in to kind of tweak the configuration for CORS. We can just leave the default settings. And let's just test this out just to make sure. So, all right, that worked. Not sure why it took so long. And then let's just make sure we send it to users, login, and let's see if this works. All right, status, success, perfect. All right, so guys, so we are now good to go to start deploying this to production. So now we're going to move on to deploying our application into production. And you're going to see in this section of the tutorial series, we have a lot of things to cover still. So there's still a lot of things that we need to learn about Docker, a lot of best practices. So in the deployment section, what's going to happen is I'm going to show you guys how to deploy it. And we're going to start off by doing it the wrong way. And then we're going to slowly correct each mistake one by one so that you know exactly why we are doing these things. And then when we get to our final deployment scenario where we actually deploy our application the proper way and we know how to properly update our application, you're going to have a solid understanding as to why we are doing things the way that we are. And so keep in mind for this deployment section, we do need access to a Ubuntu server. And I don't really care where this Ubuntu server is running. You can run it on DigitalOcean like I'm going to do. You can run it on AWS as an EC2 instance. You can run it on GCP or Azure as a virtual machine. Or you can just spin up VirtualBox and then run a Ubuntu instance on your local machine. It doesn't really matter. You can follow along. And even if you can't, I still recommend you finish the rest of this video because we still have a lot more things to learn and a lot more things to cover. So don't think that this is just about the final step and we just got a couple more things to do and then we're done with the video. We still have a lot of things to learn. So definitely stick to watching this video even if you can't follow along with all of the steps. All right, so let's now get our Ubuntu server up and running. And like I said, we're going to deploy this on DigitalOcean as a droplet. However, if you want to use a different platform like AWS or Azure, or even run it as a virtual machine on VirtualBox on your local machine, feel free to do that. As long as you have an Ubuntu server someplace, you should be able to follow along with everything that I do. But I'm going to specifically do this on DigitalOcean. So if you guys want to see these exact steps to do this on DigitalOcean, it's pretty straightforward as well. So I'm going to click Get Started with the Droplet. And then here I'm going to select Ubuntu 20.04. We'll select the basic plan. And then we want to select regular Intel with SSD because it's cheaper. And then we select the cheapest option that we can find. And then by default, because I'm on the East Coast, it's going to default to the New York data center. Just pick whichever data center is closest to you geographically. And then we want to select our password. So put in your password here. Then we just hit Create Droplet. And so we'll let this run for a couple minutes. It does take some time for DigitalOcean to spin up a new VM. And then once that gets started, we'll then install Docker. We do need to install Docker on our production environment because that's how our application runs, obviously. So I'll see you guys in a minute or so. All right, so our droplet was created. We can see our public IP address. So let's copy that. And then I'm going to open up my terminal. Make this bigger for you guys. And then here we just do SSH root at, and then that IP address. And then we're going to say yes, and then put in our password. All right, and so now we're logged in. And the first thing that we have to do is get Docker installed. And so there's a couple of different ways to do this. So if you pull up the documentation for installing Docker Engine on Ubuntu, they've got some very easy steps to go through. It's just a couple of commands. However, there's an even easier method. So if you go to get.docker.com right here, there's actually a script that's hosted on this website that actually installs Docker for you automatically. So you just have to run one command. So here under this section right here, you just copy this curl command. And so all you have to do is copy that, paste it in here. And then what that's going to do is it's going to download a file called getdocker.sh. And then we can just say sh get-docker.sh. And so that's going to run through all the steps for getting Docker. And it's really just running the same exact steps here, but this just requires 2 commands. So I think it's a little easier, and that's the route that I'm going to go. All right, so it looks like it's completed. Let's verify that Docker was installed by doing a docker -- version. And we can see that it spits out a version, which means Docker was successfully installed. Now, this only installs Docker. If you try to do docker -compose -v to get the version, it looks like Docker Compose is not installed by default. So let's get that installed. Let's pull up the directions. So we'll say Docker Compose install Ubuntu. And then here we can just select Linux here. And we just copy this command. Paste it in there. And then copy this command. So now if we do docker -compose -v, we should see it return a version. All right, and so now we've got Docker installed on our Ubuntu machine. In the next video, let's set up Git for our application so that we can store our application in a Git repository, and then we can pull it into our production server. All right, so let's get started on creating a Git repo for our application. So on logged into GitHub, we're going to hit this plus sign, and we're going to select new repository. We'll give it whatever name we want. So I'm just going to call this node docker. And then you can make it public or private, but for practice, I'm just going to leave it as public. We'll create repository. And it's going to give us a couple of commands to run to initialize it. So I'll walk you through that. I'm not going to follow those exactly. So we're going to do git. Actually, before we even get started, first of all, let's create a git ignore file. So we'll say .git ignore. And we want to make sure that we don't include our node modules files because we don't actually need those in our Git repo, because we can just copy all of our source code and then just do an npm install. And then based off the dependencies that we have listed in our package.json, basically Node will know exactly what packages to install. So we don't ever need to actually push all of our Node modules into GitHub. So we just say node underscore modules / that's all. Save that. We'll do a git init. Then we'll do a git add -- all. So it's going to add all files. And then we want to copy this git branch -m. Actually, we'll do a git commit first. We'll do git commit -m first commit. And then we'll do git branch m. And then finally, we'll copy these last 2 lines right here. Going to set the remote repository, and then we want to push those changes to our repository. All right, so all of our changes should get pushed out. And so if you just click on this link right here, you should see all of your files and everything looks good. And so in the next section, we're going to make a couple of changes to our Docker configs for production so that it's ready to get deployed for our production server. All right, now let's open up our source code and let's go to our Docker compose .dev. And so you'll see here that there's a couple of environment variables that we need in our application for it to work, right? So first of all, we need the Mongo user, the Mongo password in our Node app, and then we also need our session secret. And then under our Mongo server, we need a couple of things. So we need the root user and then the root password. So here we are hard coding it into our Docker compose.dev file because this is our development environment. And so these are all just for practice and for test. But you definitely don't want to accidentally push any of your production secrets or configs or passwords into GitHub, right? Because if we put our environment variables all here, then all of our production passwords and secrets would automatically get pushed into GitHub. So the way around this is what we're going to do is we're going to get all of those environment variables from the machine that Docker is running on. So from this Ubuntu machine, we're going to actually configure the environment variables. And then from there, Docker will know what those values are. Docker will pull all those usernames, those passwords, those root users, those root passwords from our host Ubuntu machine. And so from a configuration perspective, right, here we have all of these environment variables. I'm going to copy this and we're going to tweak something. So under environment, we already have it right here, actually. We're going to paste this. We don't need the development one anymore because we're in production. And so instead of hard coding it to whatever our production username is and our production password is, what I'm going to do instead is I'm going to just make one minor change. I'm going to put a $, then brackets, remove this, and then say Mongo underscore user. And so what exactly is this saying? It's saying that the environment variable called Mongo user is going to pull this value from an environment variable named Mongo user on our Ubuntu machine. So if we define an environment variable on this Ubuntu machine called Mongo user, then Docker will be able to pull it from there. And so that way we never have to actually store our passwords in our Dockerfile. So we don't need to worry about it accidentally getting pushed up into GitHub. And so I'm going to change this as well. And then we're going to change the session secret as well. And then we're going to have to define the same thing for our Mongo service. And we can see here we have this these two values right here. So we're just going to copy this. Paste it in there, and then do the same thing here. All right, and I want to quickly show you how we set an environment variable on a Linux machine. It's actually really easy. All we have to do is we type in export, and then the name of the environment variable. So let's say, as an example, we set session secret, right? We can set session secret equal to some arbitrary value, and I'll just say maybe hello. And then if we do print env, so this command right here, this is going to print out all of our environment variables. So let's see if we can see our session secret, and then we can see our session secret is set to hello. So this value will then get pushed into this variable right here, which will then get assigned as an environment variable into our Docker container. And so that's how we're going to handle environment variables within our production server. All right, so now let's get the rest of our environment variables onto our production machine. So we could go one by one and just say, export, and then, Mongo _ initdb and so on, and just configure all of those manually. However, that's kind of a slow process. And on top of that, it won't actually persist across reboot. So I want to show you my method of getting our environment variables set on our machine that'll actually persist through reboot. So if the switch goes down, comes back up, it's automatically going to load all of our environment variables. And so the first thing that I want to do is I want to create an environment file that's going to store all of our environment variables. So here I'm under my root folder. I'm just going to make that file, store that file here. I'm not saying you should be doing anything under the root user. I don't want to go into all of the security best practices. You probably shouldn't be doing anything as a root user, but I want to keep this video as simple as possible. So pick a location in your system. The location doesn't matter. The only thing that I would recommend is don't put this anywhere near where your application code is going to get stored. And so that way you don't accidentally ever push this up into Git. That's the only thing that matters. So I'm going to store it under /root. And I'm going to say .env, so vi.env, that's going to create our environment file. And then here, we just store all of our environment variables. And so I'm just going to grab them from the dev file right here, and we just copy the same exact syntax. So this is going to be what we're going to set this to prod, of course. And then the last two are going to be the ones for Mongo. And that's all we need to do. So we've got our environment file. Then if I do a pwd, make sure you're in your root folder. And if I do an ls-la, this is going to show us this profile file. So we're going to open that up. And I'm going to go to the absolute bottom of that file. And I'm going to create a simple config right here. And I'm going to say set-o all export. And then source. And then we want to provide the path to that environment file. So that's going to be /root .env. And then we say set +o all export. All right. And so what's going to happen is that it's going to loop through all of those environment variables that we set, and it's going to set them on this machine. Let's save that. And these changes won't take effect until we close out our terminal session and reopen it. So I'm going to just exit out of here. It's going to take me back to my local machine. Then we're going to SSH back in again. And now I want to do a print env. And let's make sure all of our environment variables are set. So we've got our Mongo password, perfect. We've got our Mongo root user. I believe it should be, actually, let's just see. If I do a cat.env, there's a 1, 2, 3, 4, 5, 6. So we have 6 of them. So this is 1 right here, 2, 3, 4, 5, and then 6. All right. So we've got all of our environment variables set. I'm not saying this is the best method. You can use whatever method you want. Some people don't like having a file on their machine with all their passwords. They may use some other method of assigning secrets. So use whatever method you prefer. I'm just showing you guys one example of how to do that. All right, so we've made some changes to our Docker Compose file in the last video when we assigned these environment variables to be whatever was set on the Ubuntu server. And so what we need to do is we need to add these to Git. So we'll do a git add -- all. Actually, first of all, let's make sure I save it. It looks like, I guess we pushed those changes after we made that. I don't think we did, but let's just say git commit -m env changes. Okay, so there we go. So we made a couple of changes. And then we want to do a git push. And then let's go back to our Git repo. And let's open up my dockercompose.prod file. Let's just make sure the updates got taken. And it looks like they did, so perfect. So now that we have our final application code within Git, let's go to our production server. And let's, first of all, let's create a folder to store our application. So I'm going to create a folder called app. I'm going to cd into app. And then we're going to clone our Git repo. So let's copy this. I'm going to say git clone, and then clone it into our current directory. And so now if I do an ls, we should see all of our application files. And so now, just like we did on our local machine, let's run a Docker Compose up, and let's see if this works on our production server. We're going to say docker-compose, and then we're going to say -f, and then we'll do docker-compose.yaml, and then -f, and then docker.compose.prod.yaml. We'll say up with the -d flag. And because there's no images already on this machine, because we just installed Docker, it should automatically build our node image as well. So let's run that. And I realized I made a mistake. So you can see here, this should be indented one slot back. I'm not sure what happened in my production example, but that got a little rearranged. So just move that over. And that's why he was saying that there was an error on that specific line. So we got that fixed. Now, unfortunately, we have to do a git add again. And then a git commit. And then a git push. And then we go back to our server and we could just do a git pull. All right. And so now we got those changes. And now let's run that same command. All right. So it's building our image. Perfect. All right. And now it looks like it's finished. Let's do a Docker PS. We can see that we've got all of our containers up and running. And now let's go ahead and actually just send a request to our server. So I'm going to pull up the IP address of my DigitalOcean droplet. And then let's go back to Postman, and I'm going to just create a new request. So we'll go to http:// put that IP in. We don't need to put in a port because it's listening on port 80, so you could do that, but it's the default. And then here we want to go to /API/v1/ we'll just get that one. Let's just see if that works. All right, and we can see it says hi there, so it looks like things are working. But I also want to log in, so we'll do users login. Well, actually, we have to do sign up because remember, we deployed this on a different server, so there's nothing in our database, so we have to actually sign up first. And let's set our body. We'll do raw, then JSON. And then here we'll say username, Sanjeev. And then we'll say password. And this is going to be a post request. All right. And it looks like that works. So it looks like, I think it's pretty safe to say that our application is now working in our production environment and everything has been deployed properly. All right, so now we have successfully deployed our application to our production server and we can start receiving and handling production traffic. But how exactly do we go about pushing out changes to our production server? let's say that a developer on our team either made some code changes or maybe even added a new feature. How do we get those changes that we implemented in our development environment pushed out to our production environment? Well, let's walk through the different steps that's going to be required. So the first thing is I'm going to make a simple code change. So under this dummy route that we have in our index.js file, I'm just going to add a few exclamation points like I've done before. So let's save that. And the first thing that we have to do is we need to push that out to GitHub. All of these changes need to be pushed out to our repository. So let's do a git add -- all. And then we do a git commit. We'll commit those changes. And then we'll do a git push. All right, so those got pushed out to GitHub. Let's just double check to see if those changes are there. So I'm going to select the index.js file. And if we take a look at our route, we can see we have the extra exclamation points. All right, so now we have to go to our production server. It looks like I lost connectivity, so let me log back in. Make sure you cd into your app directory. And so here we need to pull in those new changes. So we have to pull in the updated code, so we just do a git pull. And so once you do a git pull, it should update that index.js file. And if I do a cat index.js, we should see those changes take effect, and we can see that here. All right, and so now, because this is our production environment, it's not going to automatically sync our code, or anytime our code changes, we don't have nodemon to restart application. We have to rebuild an image and create brand new containers. So we have a couple of different options. We can do a Docker compose and then down. And then after that, we do a Docker compose up. Or we can just do a Docker compose up. And I prefer just doing a Docker compose up because it's a little bit quicker, because the system or Docker compose will actually delete the container and spin up a new container. Whereas when we do down, it tears everything down. And then until we run the up command, it's going to keep everything down. So when you do down and then up, you face a little bit more of an outage. So let's do Docker compose, and then let's pass in our files as usual. And then let's do up and then -d. So let's see if this updates our code. All right, and so we could see here, it looks like Docker compose detected that the Mongo database is already up to date. We don't need to change anything, and that's expected because we didn't change anything with that. Same thing with the Redis, same thing with Nginx. However, for some reason, it did not update our Node app, right? It says it's already up to date. And remember, that's because Docker compose is very dumb, right? It just checks to see if there's an image named that. It does not know that this image is out of date. So what we have to do is we have to run the same command with the -- build. So let's run that. And this should rebuild the image. And then since the image has changed, Docker compose is going to have to delete the old container and spin up a new node container. And so you can see here, it's now recreating that container because the image changed. And it noticed that, Mongo didn't change. Once again, Redis didn't change, and Nginx didn't change. So if any one of those properties for any of these containers had changed as well, then it would update those as well. All right, so the changes are done. And let's go to our Postman, and then let's send a request to that route. So let's hit send. And we can see that we got a response back with the extra exclamation points. So we have now successfully pushed out changes to our production server. However, there's a couple of things I didn't like. So first of all, when you do this up -d -- build, it's going to check all of your containers, all of your services to see if anything's changed. Now, in our application, we know the only thing that's going to be changing whenever we change our source code is going to be our Node app container. So is there any way that we can tell Docker compose to not even bother checking these things? Because we don't want to accidentally, maybe we put in a typo into our compose file and then we accidentally change some settings in our Mongo database, and that causes our Mongo database to go down and then have to get rebuilt, and then we suffer an even bigger outage. How can we tell Docker compose to only rebuild our Node app and then recreate that container? And then here, what we can do is we can specify the service name. So I could just say node-app, and that's just going to rebuild our Node app service. So let's test this out and see if this actually works. And so it rebuilt our Node app service, and that's good. So it built that image. However, once again, it went and checked to see if Mongo and as well as our other Redis container, probably somewhere in there, needed to be updated. So why exactly did it check that? Actually, it looks like it just checked for Mongo. So why did it check to see if our Mongo database was up to date? Well, Despite the fact that we provided the service here just as Node app, what happens is if you take a look at our configuration and go to our Docker compose.yaml file, you'll see our Node app is dependent on Mongo. So within Docker Compose, anytime you specify a service and you need to rebuild that service, it has no idea if all of its dependencies changed. And when I say dependencies, I mean under the depends on. So it has to rebuild the Mongo container because it has no idea if the changes will impact Mongo or not. So that's the reason why that's happening. And there's a way around that. What we can do is we can pass in one more flag. We can pass in the no deps. So we're basically saying no dependencies. So we're not going to rebuild that Mongo dependency as well. So if we run this now, you can see that it successfully builds our image and then it rebuilds our container. And you can see it's already up to date because we didn't make any code changes. So let's test this out one more time. Let's push out some changes. So I'm going to go to my index.js. I'm going to delete this. I'm going to save that. I'm going to do a git add. And then we'll do a git push. Changes have been pushed. Let's do a git pull. And then let's run this same exact command. And let's just hope that only our node container gets rebuilt and recreated. All right, so it recreated our container. And so now if I send a request to that route, we can see that we don't get exclamation points. Now, there may be an instance where maybe you just want to rebuild a container. Let's say we didn't make any code changes. The image hasn't changed, and we just want to rebuild a container for whatever reason. There's a couple of specific flags that we need to pass in. So let's do a Docker compose up -d. And let's say we want to rebuild the Node app service. If we do this, well, here's the problem. Here's the problem, right? None of the images change. So if we just run this, it's not going to rebuild it because it's going to say that it's up to date. So what we can do is if I do a --help, and I need to paste that here, we can do the force recreate. So this will recreate containers even if their configuration and images haven't changed. So let's try that out. We'll just say --force recreate, and we'll say node-app. So let's see if this recreates our node container. And two things happen. Well, first of all, it recreated our Mongo container. That's not good. And then it recreated our node app. So remember, it recreated our Mongo container because in our Docker compose file, we say it depends on Mongo. So because it depends on it, we got to rebuild that also. And so to get around that, just like we did before, we can pass in the no deps argument. So we can say no-deps. And this is going to trigger a rebuild of that container and no other containers. So I want to quickly summarize our overall development to production workflow, and I want to quickly reiterate how we actually push changes from our development environment to our production environment. So whenever we make any kind of change to our code base, the first thing that we do is we push it out to GitHub. And then once we push it out to GitHub, our production server will log in, and then we'll do a git pull, which is going to pull that new code base in. And then once we get the updated code, what we're going to do is we're going to run the Docker compose up --build. And that's going to trigger a rebuild of the node image. And then once we build the image, we can then rebuild a brand new node container using that new node image. So there's a couple of different issues with this development to production workflow. And the main issue is that we're building our image on our production server. This is something that is never recommended. You should never be building your image on your production server. And that's because building an image takes resources. It takes CPU cycles and it takes memory. And for our application, it's obviously a tiny demo application, so it doesn't take that much CPU horsepower to actually build that image. But as your application grows, right, it's going to require larger and longer build times. And so, as that application grows, you're going to see that when you build an image, it's going to take more CPU and it's going to take more memory. So if you do this on a production server, you could end up starving your actual production traffic because all of the compute power and all of your memory is going towards building an image. And your production server should only be meant for one thing, and that is just to handle production traffic. It should never be doing anything else. So what I ultimately want to do is move away from this development workflow and move towards a workflow that allows us to build an image on a machine that's not our production server. So let's take a look at the production workflow that we're ultimately going to move to. All right, so in this workflow, the main idea is that we're no longer going to build that image on our production server. So what's going to happen is the engineer on the left, he's going to build an image on his dev server. So he builds it on his dev server using a Docker compose up -- build. And so that's going to trigger a build on his local machine. Once that's done, he's going to push that brand new built image to Dockerhub. So Dockerhub is just a repository of images. You can use any Docker repository. It doesn't have to be Dockerhub. You can use Amazon's repo repository. But when we demo this, we're just going to use Dockerhub because it's free. So we'll push that image to Dockerhub, and then our production server, we're going to pull that brand new node image. So we're pulling in the finalized image with all of the new code changes. And then all we have to do is do a Docker compose up. Docker compose is going to detect that there's a brand new image for our node container or our node service. And that's going to trigger a rebuild of the node container using the brand new node image. So this is the workflow that we are going to move towards. And you can see that by building it on the dev server, we no longer have to build it on our production server. So next video, we're going to actually go ahead and implement this, and I'm going to show you guys how much better of a workflow this actually is. All right, so to implement our new workflow, the first thing that we have to do is create an account on Dockerhub. So if you haven't already done that, go ahead and sign up to Dockerhub and then sign in. So I'm going to log in real quick. And so once we've logged in, this is going to be where we store all of our repositories. So I'm going to create a brand new repository, and I'm just going to give this name Node App, and I'm going to make this public. So Dockerhub gives you one public you get unlimited public repositories. You get one private repository. So I'm just going to keep that as public for now, and then we'll hit create. And so now let's push our image that we have on our development server up to this repository so this repository can store our final image. And so to do that, the first thing that you have to do is let's go to our development environment and let's do a Docker. And then there's a command called push. And then let's just do -- help just to kind of poke around and see what options we have. So it looks like we just do Docker push, and then we just do the name, and then, colon, and then tag. So if we do Docker, well, first of all, let's do Docker image ls. And let's grab our latest Docker image for our Node app, which is this one right here. So what I'm going to do is I'm going to do a Docker push, and then this, and then if I don't pass in, a specific tag, it's just going to assume to be latest. So let's try that. And we may have to do a Docker login first. All right, so we're logged in. Let's try a push again, and let's see if that worked. And it looks like it's denied. And so the reason for this is that when you push an image to Dockerhub, it needs to have a very specific name. So if we go here, this is the name of our repository. This is the name that we have to push it as. So we have to do sloppy networks, which is my username. So you have to use your username, whatever that is, and then / and then the name of the image. So we're going to change that. So how do we change the name of an image? Because right now, if I look at my image, it's called this. And you can see I need to rename it to something like sloppy networks / node app. So to do that, we have to do the command Docker image, and then there's a command called tag. All right. And so what we do is you grab the name of your current image that you want to rename, and then you want to then pass in the name that you want to rename it to. What it actually does is it copies the image and then gives the new copied image the name that you tell it. So I'm going to name this my username. Make sure you put in your username / and then we'll just say, what was it called? Node-app. All right, now if I do a Docker image ls, scroll to the top, we can see that we now have sloppy networks / node-app. And it's got a tag of latest because we didn't give it a tag. So let's push this up now. So let's do a Docker push. copy that name. And so now we can see that it's successfully getting pushed. All right, so now that that's complete, if we go back to Dockerhub and refresh this page, we should see that an image was successfully pushed. And so we can see that we got an image that was pushed a few seconds ago. And so now it's within this repository and our production server can pull that image. However, before our production server can actually pull this image, we need to tell Docker Compose that we want to actually use this image for our application moving forward. So how do we do that, right? Because we still need to be able to build our image ourselves with Docker Compose, but we also need to be able to tell it that, when we want to actually run the application, we want to use this specific image in this repository. So what we have to do is let's go to dockercompose.yaml, and under node-app, what we can do is we can pass under here an image property. And here you just pass in the name of that repo. So you do sloppy networks/node-app. So once again, your username and then the name of the project. And so now when you do a Docker pull, it's going to pull this specific image. And you can still technically build an image as well. So you get the flexibility of being able to build an image as well as pulling the image from the repository. Now, since we made some changes to our Docker Compose file, we do need to push that to GitHub and then pull those changes onto our production server. So let's go ahead and do that right now. I'm going to do a git add --all. And then on our production server, we just do a git pull. All right, so now what I want to do is let's go ahead and do a Docker Compose up -d, and let's just see what happens. All right, so it rebuilt an image just because now our image is actually called sloppy networks/node-app. So when we actually build an image, it's by default going to give this name. So it built that image on the production server local machine. It named it sloppy networks/node-app latest, and then it recreated the application, and nothing's changed. So we've got it working now, but how exactly do we push those changes now? So let's say in our development environment, we make some code change. So let's go back to index.js and let's make some changes. I'm going to add some exclamation points. So how do I actually push those changes, right? Well, remember, what we want to do is we want to build an image on our local machine and then push it up to our repository on Dockerhub. And then once it's pushed out to our repository, we'll then pull it onto our production server. So how do we build an image? Well, we already know how to build an image. However, we can use Docker Compose to do that as well. So let's see if I can find the command. So we'll do docker-compose. And you got to do the -f and everything again. So we'll do docker-compose.yaml. And then -f once again, and then docker-compose.prod.yaml. So we always want to do the .prod because we're building the image for production. And we want to run, instead of up, right? If we do --help, we can actually do a build. So just like when it comes to Docker, like Docker build or Docker push and things like that, we have all the same commands for Docker Compose. So we want to do Docker Compose build. That's going to build all of our services. So we'll do build. And what this is going to do is for all the services that you have, and it looks like my terminal just crashed. Wonderful. And do I still have, and it's gone. So I got to rebuild that for a sec. So give me 1 second. And then we do build. So what this is going to do is, if we go to our Docker Compose, it's going to look through all of our services that allow us to build an image, right? And so right now, we only have one custom service where we have to build an image. However, if we had more than one, maybe we had a couple of other services that required building images, it would build the image for all of those services. So if I do build now, right? It's going to go through that whole process. It's built the image. If I do a docker image ls, you can see we have a sloppy network /node-app, and you can see this one was built 5 seconds ago. So this is the one that we're concerned with. And so now that we have this image, we can then push it up to Dockerhub. However, one thing I want to point out, like I said, it's going to build all of our services. And in this case, it's just our one Node app service because we only have one service where we can build a custom image. However, in a production application, you may have more than one service. So let's say we only wanted to build the image for just one of our services. Is there any way we can specify that? Absolutely. All you have to do is just pass in the name at the end of the service that you want to build for. So here, this is only going to build the Node app service. All right. So we got our image. The next thing we have to do is push to Dockerhub. So just like we have a build command, we also have a push command. So we can say push, and this is going to push it to Dockerhub. And you have the option of pushing all of your images for all of your services, which if I just hit enter right now, it's going to do that. Or we can also specify just the services we want to push an image for. So if I do node-app, it's only going to push the image that we built for this service. But if we have more than one service, then we could theoretically push all of them out if we just don't specify the name of a service. So I'm going to just push out just this service. And remember, the change that we made was we added the extra exclamation points. All right, so we push that image. We go back to Dockerhub, hit refresh. And you can see once again, it was pushed a few seconds ago. And if you wanted to see all of them, it's going to show you that, but let's go back. And now let's go to our production server. And instead of running an op, we just do a -- help. And let's see if there's a option to pull an image. All right, so now if we take a look at the list, it looks like there is a way to pull a service image. So let's try that. I'm going to say pull. And let's see what happens. All right, so it looked like it pulled all of our images. So it went back to Dockerhub and checked to see if there was a more recent Redis image. Same thing with Nginx, same thing with Mongo. And then it pulled our brand new Node app image. So if I do a docker image ls, you'll see that this one was created about 3 minutes ago. I guess it didn't have to update this, but I'm not sure why that didn't get updated. But let's try it out anyways. And so what we're going to do is let's do a docker compose up now with the new image, and just pass in -d, and let's let it run. So we checked to see if these images were up to date, and they were. And it looks like we were running an older image. So now that we got the new image, it's going to rebuild our container. And now it's running our latest image. So if I hit send, we can see that it now has the exclamation points. All right, so it looks like we now have somewhat of a better development to production workflow by pushing and pulling images. But a couple of things to note. So first of all, it checked to see if all of these images were up to date. There may be times where we don't want to pull the latest image for those. So just like we did before, we can do up -d, and then we can say --no-deps, and then we can specify we just want to specifically update the Node app. So in this case, it's just going to try and update the Node app in this case. All right, so let's run through this workflow one more time just to make sure you guys understand what we have to do. So let's go back to our development environment. I'm going to change this back to here by removing those. And so the first thing that we have to do is, once we make those changes, we have to build an image. So we run a docker compose build, right? And we have the option to specify just one service or more than one service or all services. I'm just going to specify this one service. We'll hit enter. It's going to build that image. Next thing we have to do is we have to push this brand new image that we created to Dockerhub. And so we can do let me hit the up arrow a couple of times. So then we do a Docker compose push. And once again, we can push all of our images or just one image. So in this case, we're going to push just the Node app image. So let's run that. It's going to push it up to Dockerhub. All right. And so now once that's pushed up there, let's go to our production server. And then here we pull that brand new image. So we do a pull, and here you can also specify just the service that you want to pull an image for. So I'm going to specify just the Node app because that's the only thing we're updating. And so now it's going to pull our Node app. And then we can run a Docker compose up and specify just the services we want to change. So if we run just an up, this is going to try and it's going to check to see if there's changes for any of our services. And if there are, it's going to change all of those services. However, we didn't change anything with our databases, so nothing technically needs to change. But in a production environment, if you know nothing should change, I would just rather just hard code it to say I only want to update my Node or Express app just in case, because I don't want to accidentally rebuild a database or my Redis data store or any other important aspect of my application that doesn't need updating. So I'm going to pass in the --no-deps and then specify node-app so that we only can rebuild just that one service. All right, so we're recreating the container because we're using a brand new image that we pulled. Once that's done, let's test it out. And so now the exclamation points should be gone. And now they're gone. So that's our development workflow at the moment. In the next video, I'm going to show you how we can automate one of those steps. And you'll see that, I'm not saying that you do want to automate that specific step that we're going to do, but it is an option. I just want to make sure I cover everything in this video. So in the last video, I walked you through how we can implement our new development workflow by pushing and pulling images. And one of these steps we can actually automate. So, when we push a new image to Dockerhub, wouldn't it be cool if there was a nice way to have the production server automatically detect that we pushed a new image and pull that new image? Well, there is a tool that we can use called Watchtower that will automatically check Dockerhub periodically for a new image. And whenever an image gets pushed, it'll automatically pull it to your production server and then restart your container with the brand new image. Now, some people, like this feature, some people don't, right? Some people don't like to automatically push out changes to their production server because, they want to manually do it so that they can verify that everything runs okay. Because you don't want it to accidentally pull an image and then, have it potentially crash out with some error logs while you're not there at the command line. So, some people like it, some people don't, but I did want to show you guys how we can automate that step. So here in Google, I'm just going to quickly search for Docker Watchtower. And so here, this is the GitHub page for this. And what we want to do is just go to the full documentation page. And this is going to have a quick start for you. So it's going to show you how to actually use this feature, but it's a special container that'll just periodically watch Dockerhub for a specific image. And if it sees a new image get pushed out, it's going to pull that image automatically for you and restart the container. So it's a container that handles the automation of your other containers. And there's plenty of documentation, but I'm just going to show you guys how to run this real quick. And let's go to our production server. So let's do Docker PS. You can see all the containers we have, and that's just for our application. And what we're going to do is we're going to do a Docker run -d. There's going to be a lot of flags, by the way. So let's give this container a name. So I'm going to say name Watchtower. And then we're going to pass in some flags, some environment variables. So we're going to call this Watchtower _trace. And if you're wondering where I'm getting these, just take a look at the documentation. So you can see under arguments, I think it's under here, you'll see all of the environment variables. And if I search for trace, so it's going to show us, this is just going to include trace mode with verbose logging. So I like having extra logs. And then we're also going to pass in the poll interval. So this is going to tell us how frequently we should poll Dockerhub. So watchtower underscore trace is going to be set to true if you do want the trace on, or you can set it to false. Then we're going to pass in one more environment variable called watchtower underscore debug equals true. And then one more. This is going to be watchtower underscore poll underscore interval. This could be set to 50. So I think that should be every 50 seconds. We should check for a new image. And then we have to set up this volume. So this is just comes straight from the documentation. So we do /var/run /docker.sock and then :var/run/docker.sock. And that should not be in all capitals, by the way. And then we have to specify the image. So the image just comes from that repository. But if you look at the homepage, you can see that the image is just container/watchtower. That's container with 3 R's, by the way. All right, so now if we do a Docker PS, we've got our new container. It's running. And let's just do a Docker logs and then just grab this container and then pass in the -f flag. All right, so it looks like it's running the list of retrieved containers, and I realized I made a mistake. So there's the one important thing that we have to pass into this Docker run command is the list of services that we actually want to watch, because right now it doesn't know which services we want to watch. So let me stop this. And let me just do a Docker RM. And then we'll just use a -f flag to delete it. And then we're going to run that long command again. But here we have to specify the services or the containers that we wanted to watch out for. So in this case, we have this app node app1. So we wanted to make sure that there's that if a new image gets pushed for this container to Dockerhub, that it automatically pulls it. All right, so you could specify as many different containers as you want. So I'm just going to use just this one. And then now let's do a Docker logs watch. All right, so now retrieve running containers. And then basically nothing's happening except it's saying that a check will be performed in 49 seconds. So let's make a change to our code and push an image. So I'm going to add quotations and then some extra fun stuff. We're going to do the 2 usual steps. We're going to do a build. And then we're going to do a push. And then let's take a look at the logs and let's see if after the time limit, after the 50 seconds, it does successfully detect that there's an image and it rebuilds our container. And look at that, something happened. What happened? Let's see. So this is where we were. All right, then it's checking. So the 50 seconds in, it's going to check for containers for updated image. It retrieved the running containers. All right, trying to load authentication credentials. No credentials for sloppy networks found. And we were still able to get an image, right? So this, remember, this is the reason why it's checking for credentials is because there's a possibility that one of my images or one of my containers uses a image from a private repository. So if it did use a image from a private repository, we would have to make sure that we just did a Docker login, right? So it would look like Docker login, and you would just do this on your production server. And then, you know, if you aren't logged in, it's going to actually ask for credentials. So let me log out just to show you what that looks like. So now that if we do a Docker login, you would then put in your username. And I already messed that up. And then your password. So if you are using a private repository, make sure to do that on your production server so that your production server can actually access it. But so we don't actually need it. Not a big deal because it's a public repository. We got the image that our container's using. So our container's using sloppy network /node app. We're checking if pull is needed. So now it's basically querying Dockerhub. And then it's going to do a few other things, I guess with like authentication and a few other things like that. Right. So then it says it's determined that there is a new image. So it's going to do a pull. So it's pulling the new image. Then it stopped our container. It's deleting our container. It's creating a brand new container. It's then starting the new container. Right. And then after 50 seconds, it's going to do all of the same stuff over again. All right. So let's test this out. So remember, we didn't do anything. This was all automated. So if I hit send, you could see all the changes that got pushed out. So we've automated that last final step in our development to production workflow where we pull the image into our production server, and we're letting our production server automatically do it for us using this watchtower container. And let's just test it out just to make sure that it works fully again. So I'm just going to delete these. I'm going to do a Docker build. And then let's do a Docker push. And you can see during the last run, it said no new images were found. So, it's pretty smart at being able to detect when a new image gets pushed. So let's give it another 30 seconds or so, and we should see those changes get applied. So right now, we're still using the old image because we still have all those extra characters. But once we see this update, we should then be able to send a request and get the updated code. All right, so it ran. So it looks like it updated. So it's stopping our container. Give it a few more seconds to create a brand new container. All right, and so now it's good to go. So let's test this out. Hit send, and there we go. Now, if you haven't already done so, go ahead and delete that watchtower container. We're not going to use it moving forward. I just wanted to show you guys how you could automate that last step. So just do a docker rm watchtower-f. Now, one of the things I want to talk to you guys about is our current workflow. And that is, whether you're using Watchtower to do the pulling of the image and restarting of the container, or if you're manually doing it yourself by doing a Docker Compose pull and then an up, at the end of the day, we have to recreate the container. So we have to tear down our current container. We have to build a brand new container with a brand new image and then start that container. And during that window of tearing down and building up, we are going to experience a network outage, essentially. We are going to experience our application being down, right? Our app's going to be down until that new container gets built. So we are going to experience loss with our production traffic. And I was trying to see if there was a way we could achieve basically rolling updates with Docker Compose so that we could somehow do this upgrade process or push out new changes to our production server without experiencing any loss. And going through a whole bunch of Stack Overflow responses, there were some hacks that we could put together. Right? We could really hack up Docker Compose to do a few things so that we can almost achieve something that's similar to a rolling update. But ultimately, these were hacks. These were nothing more than hacks, and they were not recommended to be run in a production network, right? Because remember, Docker Compose isn't meant for that. Docker Compose is not a container orchestrator. It is not meant to provide you a way to implement rolling updates or anything like that. Like at the core of Docker Compose, right? Remember, Docker Compose is just nothing more than a file that maps out to different Docker run commands, right? Because a service is nothing more than a container which gets created with Docker run. So this Docker Compose file just gives us a way to basically write down all of our Docker run commands within a YAML file. And then when we do a Docker Compose up, it just runs all of the Docker commands for us so that we don't need to actually type them out ourselves. So it's not an orchestrator. So what are some options that we have to help us achieve, lossless upgrades and rolling updates? Well, we can use one of the popular container orchestrators that we have, and one of those is Kubernetes. So that's one of the purposes of Kubernetes. So that's what we're going to do. We're going to cover Kubernetes in the next section. And I'm just kidding. Just kidding, guys. There's no way we're going to cover Kubernetes in this next section. I don't want this video series to end up being a 40-hour tutorial. So instead, what we're going to do is we're going to use a built-in container orchestrator that comes with Docker, and that is Docker Swarm. And I know some of you guys are disappointed because I know you guys want to learn Kubernetes, and Kubernetes is the new kid on the block. But the reason why I wanted to show you guys how to do this with Docker Swarm is because, first of all, we already have it at our disposal. It's very easy. We don't really need to spend too much time going over the theory. And the main idea behind why I'm even showing you guys how to do this with Docker Swarm is to just show you guys what is the purpose of a container orchestrator, right? Because the idea behind this whole video tutorial series is not to show you how all of these tools work and all the ins and outs and all the flags. It's to show you how you put all of these pieces together, why we need a container orchestrator, and what it ultimately helps us achieve, right? So that's why I kind of walked you guys through all of these steps instead of just starting out with Docker Swarm, because I wanted to show you why we need a container orchestrator. So in the next section, we're going to get started with Docker Swarm. We're not going to spend too much time going through the ins and outs of Docker Swarm. We're just going to get something up and running and just show how we can implement some sort of rolling update so that we can push out changes to our production network without experiencing any loss, or at least experiencing only minimal amounts of loss. I want to quickly highlight some of the differences between Docker Compose and Docker Swarm. We already discussed some of the limitations with Docker Compose, and that is that it's ultimately not a container orchestrator. So it can't handle some of the more important lifecycle events when it comes to spinning up, deleting containers, and being able to do rolling updates and things like that. That's something that Docker Swarm can handle, right? Docker Compose is a very simple tool. It's actually meant to only be a development tool that we can use to kind of spin up containers and then delete them, but it can't do much else. And it certainly can't do things like rolling updates. And another important thing about Docker Compose is we can only use it to deploy containers onto one server. So if I wanted to be able to distribute my Express containers, maybe 5 or 6 of them, across multiple servers so that if one goes down, we'll have some redundancy with the other servers being able to pick up the slack, I can't do that with Docker Compose. That's where Docker Swarm comes in. Docker Swarm is an orchestrator, right? So there's more logic behind Docker Swarm. Docker Compose can only run just a bunch of Docker run commands, right? It's just a bunch of Docker run commands that's listed out in a YAML format. Docker Swarm has logic, has brains. It gives us the ability to, not only spin up containers, but we can distribute them across as many servers as we want. So if we've got 5, 10 production servers, we can spread them out across all of our servers. We can handle the update process. So if we need to push a new image to our production server, Docker Swarm can then basically spin up new containers, update those containers, and then only once we verify those containers are up and running, we can then delete the old containers. So it gives us a little bit more flexibility when it comes to our production environment and giving us some more tools that Docker Compose doesn't provide us. And when it comes to Docker Swarm, like I said, Docker Swarm gives us a multi-node environment, which means we can use multiple servers to deploy our applications. We don't need to run everything all on one server. And so each server within a Docker Swarm is referred to as a node. And we've got 2 different kinds of nodes. We've got manager node, and we've got a worker node. I'm not going to go too much into the details of it, but just, I think just based off of those names, you have an idea as to what each one does. But a manager node handles all the brains behind everything, right? The manager node is the one that pushes out tasks to the worker nodes, and the worker nodes carry out those tasks. So the control plane is going to reside on the manager nodes, and then the worker nodes just run tasks that it receives. And keep in mind, a manager node can be both a manager node and a worker node. And I think that's what the default configuration is. So that is something to keep in mind. But in this video series, we're just going to have one server. So we're just going to use Docker Swarm to spin up one individual node that's both a manager node and a worker node to deploy our application. And you might be thinking, well, if we're just using one node, is there potentially any reason why we don't just go for Docker Compose? Well, first of all, things like rolling updates, those are things that we can't do with Docker Compose. And Docker Compose ultimately is not a production-ready tool. It's a development tool. So you shouldn't be using it for your production environment unless it's for like some fun little home project or things of that nature. So let's get started with setting up Swarm in our production environment. And like I said before, Docker Swarm actually gets shipped with Docker. So when you install Docker, you already have Docker Swarm at your disposal. The only problem is it's disabled by default. If you do a Docker info, it's going to let you know whether Swarm is enabled or not. And we can see here Swarm is set to inactive. So to enable Swarm, all we have to do is Docker Swarm init. That's going to initialize Swarm, and we're going to get an error. And it's basically saying that, we've got multiple IP addresses. We have to tell what IP address we want to use for Swarm. So it looks like DigitalOcean gives us 2 IP addresses, one on Ethernet 0, one on Ethernet 1. Let's just grab the one with the public facing IP. And then we just need to pass that into the advertise-addr flag. So let me copy my public IP. All right, and so now it says Swarm is initialized, and it defaults us into being a manager. And keep in mind, when you're a manager, you're also a worker by default. And if we wanted to add more nodes into the Swarm, it provides us 2 commands. So this command is going to allow us to add a new node into our Swarm as a worker node, and then this command down here is going to allow us to add a new node into the Swarm as a manager node. But like I said, we're going to stick with just one node for now, just to keep things simple. And you'll see that, Docker Swarm is very similar to just doing regular Docker commands like Docker run, Docker create, and things like that. So if I do a Docker --help, all right, you'll see all of the commands that we have. So we can do Docker create, which is going to create a container. We can do Docker rm to delete a container. You can do Docker update to update the configuration for a container. You got Docker stop, which is going to stop a container. Well, Docker Swarm isn't really any different, right? Except instead of working with containers, it works with services. And a service, remember, is pretty much just a container. So you'll see that there's a lot of similarity between Docker containers, just running individual Docker containers, and running Swarm services. So if I do a Docker service, so this is how you get access to all of the Swarm related commands, and I just do --help, you'll see the options we have. So we have Docker service create, right? Very similar to a Docker create, which creates a container. We have ls, which is going to list out all the services. We can delete a service. And then a lot of the orchestration takes place with the rollback. So you can, revert changes. You can scale up the number of instances for a service, and then we can update specific details about a service. So I just really wanted to highlight that, there's nothing really that much different between Docker Swarm and just running regular Docker commands. And so we can do all of the things we want to do by just running Docker service commands. However, that's a little tedious, just like running all of the Docker run commands. It's hard to remember all of the necessary flags and things like that. So if you remember or you recall, when we wanted to kind of automate all of our Docker run commands, we just put all of our Docker run configurations into a compose file. And the nice part about Docker Swarm is that we can do the same exact thing. We can put all of our configurations within a compose file. And what's even nicer is that we get to use we can use our compose files that we already have. So we can use everything that we have already pre-configured, and we could just add in a few extra fields that are Swarm related. So let's pull up the documentation to see the specific Swarm related configs. So if you go to the reference section under Docker Compose and just search for the deploy section, this is going to give us a lot of the options that are specific to Docker Swarm. It's going to give us all the information that we need. And so skip endpoint mode, that doesn't matter. Labels doesn't matter. Placement doesn't matter. Here's the first flag or option that we can add to our compose file that's a little bit interesting, which is replicas. So here, the replicas defines how many instances of a specific service you want to run. So if I set replicas to 6, like in this example for my Node app service, it's going to give us 6 containers. So as our application demand grows, we can just spin up more and more containers by increasing the number of replicas. All right. There's a resources section where we can kind of constrain the resources that each container can use. We're not going to do much regarding that. Restart policy. This is going to determine when and how we restart a container. If it crashes, should we restart it? And if so, how long should we wait? So let's add restart policy as well as replicas to our configuration. So under our prod file, because we only want to run Swarm within our prod environment, we don't actually want to run it in our development environment, because in our development environment, we can just use Docker Compose. That's perfectly okay. So let's go to our prod. Under Node app, we'll just add a section called deploy. And then let's add in, well, first of all, let's add replicas. And let's set it to 8. And then for our restart policy, we can add a condition of any. So we're going to restart it for any reason it goes down. And we can set a delay between each restart attempt, but I don't really care about that. Now, this is where things get interesting. Rollback config and update config. So let's go to the update config section. This is kind of what we're most interested in because we're trying to create a way to update our application without experiencing any loss. And so this section just tells you, how do we configures how the service should be updated. So useful for configuring rolling updates. So this is exactly what we need. This is kind of the real reason we wanted to go to Docker Swarm. So here we have this flag called parallelism. So this just sets the number of containers to update at a time. So if you have 8 containers and we got to update the image of all 8, what it's going to do is if we set parallelism to 2, it's going to update 2 containers at a time. So, we can run 2, and then if once those 2 are up, we'll then move on to the next 2 containers and then the next 2. So, when 2 containers go down, the other 6 just pick up the slack until it comes back online. The delay is the time to wait between updating a group of containers. Then we have a failure action. So what should we do if an update fails? We can either continue, rollback, pause. And the default looks like it's pause. Maybe we want to do rollback if it fails so that it automatically rolls back for us. And then you can also set the order. So there's a few other properties, but let's just set up parallelism and delay for now. We're going to set that to 2, and we'll set the delay to be 15 seconds. And then there's a few other flags that you can probably search for, but that's all we really need for Docker Swarm. You can see how easy it is to integrate it into your Docker Compose workflow. We just had to add a couple of properties, and we're good to go. So we made a few changes to our Docker Compose file. So we have to actually push these changes to our production server. So we have to do a commit in Git and then do a Git push. So I'm going to do a Git add. And then we'll do a Git commit. And then we'll do a Git push. All right, then in our production server, I'm going to do a Git pull. And so now we have the updated Docker Compose file. And so now let's actually deploy it. So first of all, if we do a Docker PS, it looks like we still have all of our containers that we deployed using Docker Compose. So let me see if I can find that Docker Compose command right here up. We'll just change that to down so we can delete everything. All right, so everything's down. So now to deploy, our application using Docker Swarm, there's a command called Docker and then stack. So Docker stack is how we actually use that. And let's do the -- help and see the options we have. And there's something called deploy. So that's probably what we want. So let's do that. And let's see what options we have. Not many options, but there is this compose file. So we have to pass in the name of the compose file. And so just like we did when we did Docker Compose, we have to pass in both of our compose files. But instead of using -f, we have to use -c in this case. And then let's do a -- help again. And we want to do a, that's about it actually. So we have to, we have to give it a stack name. So a stack name is just a name of your application, right? So when we create this stack, which is, I guess, think of it as like all of your services bundled together, what do you want to give it? What do you want to name it as? I'm just going to call it my app. So let's deploy that. And so you can see it's creating all of our services. So it actually creates a network just like Docker Compose. And then it's going to create our 4 different services. And some Docker commands or some Docker Swarm related commands, you can do a Docker node ls. This is going to list out all of the nodes within our Docker Swarm. And so you can see here, this is this specific node. We only have one node in this case. If you do Docker stack ls, it's going to list out all of your stacks. We just have one stack called my app. If we do a Docker stack, and then let's do -- help, we can list out all the services in a stack. So let's do Docker stack, and then services, and then we call my app. And it's going to list out the 4 different services. So you can see the different images. This is the equivalent of doing just like a Docker PS, right? So we see, the container name or the container ID, the name it's given, how many times it's replicated. So we only have one Mongo container, and then what image it's using. And if you take a look at our Node app container, we have 8 of them. So we have 8 individual containers for that. And we can verify that by doing a Docker PS. And you can see most of these are Node app containers, 8 of them specifically. If you want to list out all of the services across all stacks, you could do Docker service ls. However, keep in mind, we only have one stack, so we see the same exact output as we saw before. All right, now we can also list out tasks, right? And I guess I didn't really go over a task, but when it comes to creating a new service, updating a service, deleting a service, Docker Swarm generates a task, and then it pushes that task out to a worker node so that the worker then can actually perform that task. So if I do a Docker service, a Docker stack PS, and then let's do -- help. And then we pass in the stack name, it looks like. So Docker PS. And so this is going to list out all of the tasks for my stack. So it's going to be called my app. And you can see all of the tasks that it created. All right. And so you can see a task got generated for each one of these containers. So it looks like it's to provision all of our containers. All right. So now let's go ahead and make a change to our application and see if we can update our production server with those changes, but with a rolling update methodology using Docker Swarm so that we experience minimal to no loss. And so if I just, first of all, actually, let's just double check to make sure our application still works. And so here we got a response and we can see it says, hi there. Let's go back to our code. And I'm going to add some more exclamation points and a few other things. Let's save that. And in this case, we want to do a build for our Node app. So we build a brand new image with those changes. And then we want to do a push of our Node app. So we push it to Dockerhub. All right. And so now let's go to our production server. And I'm just going to keep hitting the, whoa, what happened there? Let's find that Docker stack deploy command. So let's see if we just run this again, if it's able to pick up those changes. And so it looks like it's updating our services. So let's see Docker stack PS node app. Sorry, not node app, my app. It's going to list out all of our tasks. And look at what's happening here. It looks like we shut down 2 of our containers, right? And that's because of our parallelism, right? So if we go to docker compose.yaml, actually .prod.yaml, you can see we should only update 2 at a time. And then after it's been updated, we'll wait 15 seconds and then we'll wait for the next 2. So if I take a look at this and run this again to see all of our tasks, you can see we now have what? 1, 2, 3, 4. So 2 more of them got shut down and 2 new ones were created. So let's then run this again. And we should see 2 more. And so there's just a couple more of our original 8 containers that need to get updated. So you can see it's just doing 2 at a time. And while it's updating right now, if I send it, right, you can see it's been updated for some of them. Let me see if I can hit one of them, right? And so I can hit one of them that hasn't been updated, but it looks like most of them have been updated. Oh, it looks like we received an error. Like I said, even with a orchestrator, it doesn't guarantee that we won't have no downtime, but you can see this greatly minimized it. And then let's try this again. And we can see that for each one of our 8 containers, we had a previous task where we shut it down, and then we have the new one that we're running. And if I push these changes out again, so if I do this whole process one more time, delete this, we'll do the same 2 things. We'll do a build, and then we'll do a push. And then we can do a stack deploy. We don't need to pass in any other arguments. It'll check with Dockerhub to pull the latest image. And so now, if I do a PS My App, you can see that there's 2 of them that have been shut down. So it's going to do 2 at a time, like I said. And let's just run this again. So you can see I get the exclamation still for a lot of the requests. Some of them I don't, though, because like I said, 2 of those containers have already been changed. And then by now it's probably 4. And eventually, if I just keep doing this after about, it's probably going to take about a minute. But let's run this again. And you can see most of them have already been changed. All right, so it looks like all of our containers have been updated. We can verify that by just running this again. And you should see that each one should be up in a running state after the previous one got shut down. And so that's pretty much all I have for you guys for this video series. Hopefully you guys have a better understanding of how Docker works and how we can develop Node and Express applications using Docker, and how we can move from a development environment to a production environment. And I really did want to emphasize a lot of the challenges that you face when going from development to production, because Docker, it was created to simplify that process. But even with Docker, there's still going to be plenty of challenges. And so now that you guys have a basic understanding of how all of this works, you can kind of take some of the ideas that I've taught you and kind of tweak it so that you can build your own development to production workflow. Obviously, in this video, I didn't cover anything with regards to building out like a CI/CD pipeline. That would be the logical next step. So I'll probably make a video series showing you how we can actually build a full CI/CD pipeline for a Docker-based application. But I think this is a good starting point for people that just want to get a little bit more familiar with deploying apps, and as well as getting familiar just with Docker in general.